discussion will be like, so far you have studied more or less how to collect data, how to visualize data maybe, how to design a research methodology, how to define a problem, or maybe how to write a paper. Today's thing is going to be little difficult. So, difficult means in the sense ki when we have a problem, when we have collected the data, what to do with the data. Like data is like the cooking instrument, right. So, we have all the rice and all these things, like, and we cook it and make it a better dish, right. So, just like Bengalis are good in making food, right, not good in making food, but also good in making fish curry. Okay. So, we have very popular fish curries, right. We add lot of items. So, once you add lot of items in the data becomes more easy to handle and more easy to interpret and get some better inferential properties from the data. So, mostly I will try to write down a few things in the board. How many of you have studied statistics here? Just raise your hand. Statistics, okay. Many of you have studied statistics, right. So, okay, I won't ask any questions, do not worry. So, maybe what I will do, I will quickly tell you what we are going to cover, and based on that I will keep on writing on boards. Okay. So, because those who does not know, they will be knowing after today, okay. And I will share my slides, do not worry about that. So, role of statistics and data analysis, some data summarization tools we will discuss, then we will cover a little bit of descriptive statistics, what are the way to not only visualize data, but also get some sound knowledge from the data, then the inferential properties, and then finally the relationships. And we will do all this using our software in the second session. Second session means after lunch. So, after lunch do not sleep. Okay. So, let us start with what is statistics. So, I was told when I was studying at Indian Statistical Institute, which is one of the very profound institute in statistics, because we invented a lot of things. We contributed our the person who invented Indian Statistical Institute is Professor Prashant Chandra Mahalanobis. India celebrates National Statistics Day on his name. So, he is kind of the Ramanujan, right, just like Ramanujan in mathematics, he is the Mahalanobis in statistics. So, when I was there, I was told that if there is an elephant in the room, first we have to introduce it, like. So, this is the elephant in the room, statistics is the elephant today. So, I will try to introduce it, what is statistics and how it differs from other disciplines. So, we encounter data and make conclusion based on data every day. Every single day we are collecting a lot of data, we are trying to find out some methods to analyze those data. Now, what is statistics? From the mouth of Professor Prashant Chandra Mahalanobis, he defined statistics in a different way. He said statistics is a key technology. Oh my God. I think writing there would be easy, right? Maybe. Can you see that board? Maybe the front portion, right? So, I will write big size in big size so that you can see. Statistics is a key technology. Now, why he used this term called technology? He must have said it's a science, it's an arts, it's an commerce discipline, right? But he said it's a key technology. Why key technology? Because technology is used in every domain. In every sector if you go, some technological innovations are there. So, statistics will be used as a tool, as an universal tool more rather to say, which will be used in solving any problem from any discipline. So, statistics itself does not have a problem, we are kind of the helper, we are kind of the tool that is solving someone else's problem. I was doing my masters in statistics from ISI Bangalore. That time we used to have a lot of faculties, and one of the faculty has a joint project student at Karnataka University. So, a PhD scholar came that time to me because I was there with the faculty, maybe he must be knowing, it is Jijo actually. So, Professor Jijo told me, can you help her? She was doing a PhD in botany. Okay. So, they were working with all the different things, there some harvestment of honey or something like that they were working on. Okay. It's botany or zoology, I am very bad in biology. Okay. Agriculture, okay. Apiculture, okay. So, and what she had a lot of data. She had to analyze those data, and she was asking me to do ANOVA for the data, okay, that time. So that is how statistics is used. The knowledge of statistics is useful in any aspects. So be it in aerospace, be it in self-driving car, everywhere we can see the application of statistics over there. So statistics is a scientific discipline that provides method to help us to make sense of the data. So we use these methods intelligently, offer a set of powerful tools, and gain interesting insights from the data. Now you might be interested to know one thing, that where from all this came, right? The previous history, where from all these things came, why people are doing all these things, right? So let me go back to maybe 15th century, 1500. That time most of the people were interested about how nature works, and Newton was a guy, you all know the Apple guy Newton, not the Apple phone. So Newton was working on, most of the people were working on to show the existence of God, most of the people, including Thomas Bayes, who invented Bayes theorem later. They were working on how to show that whether God exists or not. Even Galileo Galilei also have shown many mathematical tools, so a lot of graphical tools he invented. So let me go back to, maybe let me draw a diagram of the things that happened over the years. So 15th century, 1500, mathematics was mostly like algebra. So people were working with arithmetic, and some algebra were invented. Descartes' rule, all these things didn't came that time. And because I am going to a French university, so French has a lot of contribution in mathematics. Lot of mathematicians, Fourier, Laplace, all these people are from France, and many of the statisticians are from India. That's what we should be proud of. So in 15th century, in mathematics there was probability. Probability was getting invented. How it was getting invented? So suppose I am a mathematician, but I am a drunkard. I drink a lot. I cannot reach my home. After drinking, I drink maybe say 20 bottles of beer, and then I am unable to look for my house. But I am a mathematician. I am an intelligent guy. So what they did? The dude actually, what he did, he tried to find out how many minimum steps and how many maximum steps we will be requiring to go from one direction to another direction, and he will walk that much step. So he solved a mathematical problem which is called, famously known as drunkard step problem. A drunkard, he will walk and he will reach from a point to another point. In how many steps he can reach? And then some mathematicians, they were very fond of poker. They used to play poker, all these card games and all these casino games with dice and everything. So what they did, they used to see that the people who are winning, why not mathematicians should win the problem? They are the best person to win this problem, right? That's from something came called gambler ruin problem. A gambler who is ruining all the money, but he tried to come up with a conditional probability theorem from which he can win the thing, win the like gamble. So all these things started happening between 15th century to 17th century. So gamblers ruin problem, the prisoner's dilemma. So suppose two of us, like suppose me and another professor, we have been convicted for the same crime, but we have been taken to the different cell, and the person came and asked, did you do it? I said yes, and he said no, but we did it together. What will be the charges? If both of them say yes, maybe we will give them 3 years penalty. If only one say yes, another say no, then both of them will be given 10 years of penalty. If both of them say no, then, so all these problems could be formulated as a probability problem, and they started working on probability problems, and mostly probability got developed during this area. A lot of people work on the development of probability. First, probability was developed as something like, if I toss a coin, I am tossing a coin, what will be coming if I toss it once, either head or tail? So the probability of coming head is half. If I toss it twice, it will be head head, either head or again head or tail, tail or head, and tail tail, right? So what is the probability of getting head, 2 heads, 1 head, 1 tail? All these things was coming from the classical definition of probability, which deals with random experiment. So, when I am tossing, I am assuming that either head or tail will come, it will not be a beat, right, it will not come in the middle. Then people started thinking, so this is not the great idea to do, right. So, the great idea would be to understand this for n tends to infinity. If I keep on repeating this experiment, so if you toss a coin for 10 times now, can you tell me how many times you will be getting head or how many times you will be getting tail? If I do it 10 times now, 5-5, will it be 5-5? I think never. If you are very lucky, it will be 5-5. But if you do it for 100,000 times, then maybe 50,000 times you will be getting head and 50,000 times approximately you will be getting tail. So, that is what called axiomatic definition of probability. It is called large number. With the large number, the definition of probability changes. And this idea was proposed by another French mathematician called von Mises. He gave the definition of axiomatic definition of probability. Then the very famous guy who was a gardener, his name is Thomas Bayes. So, he is the one of the most popular guy in the probability region. So, all of us during our high school must have heard of something called Bayes theorem, if we had mathematics or after that also. And not only mathematics or probability, Bayesian statistics is a big area nowadays. Bayesian machine learning is a big domain on which most of the machine learning problems nowadays are solved by Bayesian machine learning. So, this Thomas Bayes, he was a gardener. So, that time gardener used to be also a mathematician. So, he was a mathematician too. He came up with a theorem that probability of A given B. How do we compute the conditional probability for some system of events? So, he came up with a very nice theorem called Bayes theorem in 1760s, and later on it became very popular. Okay. Very popular means it opened a new area in statistics which is called Bayesian statistics. If statistics is defined in two different ways, one is frequentist statistics, another is Bayesian statistics. I will be maybe giving some examples a little later. Once let me finish this. From 17th century to say 1800, the development in statistics never happened. People were not interested about doing anything on that. But after 18th century, all on a sudden people started calculating astrological data. The distance between earth and the sun, the distance between different like moon and the earth, all these measures were getting calculated. Who were calculating? People who were working on that time space thing. And they had no idea, they did not still have the NASA's thing going there and putting their things out there in the orbit. That was not happening. People were trying to calculate that by some assumption, by some astrological factors, and those assumptions will validate that. That time a famous guy called Gauss is the guy who invented normal distribution. I think all of us have heard about normal distribution, right? Life is very normal, right? So, mostly if I take all of your heights, it will become normal for sure. If we have more than 50 samples, just take all the heights and put it into a frequency distribution, it will look like normal. Okay, that is the beauty of normal distribution. So, Gauss in 1809 came up with a very nice idea. He tried to solve a problem and he came up with the idea called least square estimation. I will come to that a little later. So, he invented, Gauss came here, and Legendre, another guy, Legendre, they came up in 1805 and 1809. That time there was no internet, so people used to invent things together, not together, separately, distinctly, but they used to invent the same thing maybe. Nowadays if you think something, you will first Google it and see someone else has done it already, right? Nothing is new nowadays. So, 1805, 1809, Gauss invented something called least square estimation procedure. The data he was working on was looking something like this. He had a data with x and y, the data was looking something like this. He wanted to show a relationship between x and y. He was a mathematician. What he tried to do? He tried to came up with a polynomial something like this. But he was not happy because the next point he cannot interpolate. So, the interpolation problem, if you have studied numerical mathematics, you must have seen Newton methods for interpolation, right. So, those interpolation you cannot make if you just connect these lines. This is called overfitting problem in machine learning as well these days. So he tried to come up with a line to solve this problem. He wanted to fit a line, just a line based on that will represent all these data points, the dots. He couldn't come up with that. He thought, okay, there will be an idea, why not I minimize these values. I want a line which will be very close to these points. So these are my error terms. Let's define them EI. Can I come up with something which will reduce these error terms? And he invented something called least square estimation procedure that is used in any regression model. Most of the regression model they use this. We will talk about regression model almost at the before the lunch begin. Okay. Then there came something else called the revolution. Another guy came whose name is Sir Francis Galton. Galton is like one of the biggest guy in statistics. So Galton came between 18th to 19th century. He wrote a book. He was mostly a I should say biologist actually. He was a biologist, genetic person who was working on genetics as well as he was working on mathematics. Of course, a big mathematician as well. So he was working with the idea of Gauss. Gauss invented something, how to draw this line between these points. So he needed some data, some real data. What he did? That time what people used to do, people used to have lot of brothers and sisters. Just like Galton used to have lot of step brothers, step sister and everything. And in his family he has almost 150 such brothers. That time it used to happen, like even if you ask your grandparents, they would be having lot of sisters, brothers here and there, right? They may not be knowing their name, just like the Galton. So what Galton did, Galton talked with them and Galton took their data. What data? Their height, weight, body measurements and whether they are fit or not, say. So all this data collection was not difficult. He used to send them not mail letter to them and they used to reply to that, right? If you ask someone their height and weight, nowadays you cannot do that. Maybe some people will be like, I am very fat and I am very thin, that will be a problem. That time it was not a problem. And there was a very interesting connection with Galton with someone. Galton was a step brother of Darwin. Have you heard of Darwin? Darwin? So Galton was kind of a step brother of Darwin. So they were very familiar. So Darwin was working on human evolution and everything, and Galton was defining something called correlation. Galton is the first person who named the relationship between two variables, how to name it as correlation. Galton defined actually correlation. Then there came another guy. So most of these people are either from agriculture or from biology, if you see, most of the statisticians. So in case you are in agriculture, you might be in future becoming some biostatistician, okay, or bioinformatics person. So after Galton, there came another big guy, very big guy, he is called Ronaldo Fisher. Ronaldo Fisher actually did complete change in statistics. He defined statistics. The statistics was first introduced back in 1890s by Galton and Ronaldo Fisher, and they all were working in, one was working in University College London, another was working in Cambridge University. Cambridge University is in world the first university that introduced a course in statistics in 19th century, 1900. India started their first course in 1930s at Presidency College, Kolkata under Indian Statistical Institute. So we are the third in the world to start a statistics course in the world, okay, and we contributed hugely. So then Ronaldo Fisher came and he started giving the definition of statistics, ANOVA, Fisher test, all the testing procedure that started coming. So he defined something called Z test. He had a student who wrote an answer that is alternative to Z test, which become in future the name as student T test, because students, they didn't write their names in their answer copy, right? You write your roll number. So Fisher thought, okay, some student has written it. He published it as a student T test, because the student, you asked a student writing an answer of a question, but they write a completely different answer, but that answer is correct. That's how T test was invented. And then came the F test, Fisher test, which started working for ANOVA, because Fisher was a very fond of gardening and everything. There is a very famous book that later on was written, A Lady Tasting Tea. So it is popularly known as Fisher used to go to his neighbor's house. There was a lady who used to let her drink some coffee or tea. And what Fisher used to tell, like why the tea taste becomes same each and every day. That Fisher tried to investigate. Fisher started asking a lot of questions. Do you put water first or the milk first? Do you put tea leaves first or the sugar first? Then he started doing some experiment. He started telling, okay, what if you put sugar first, then milk, what will happen? So he started testing it with all these things and came up with some brilliant idea of analysis of variance, which is known as ANOVA, which we may study today. Then there came, all on a sudden, there was an Indian guy who travelled back to Cambridge from India, whose name is Prashant Chandra Mahalanobis, and at the same time Ramanujan was there in Cambridge. Ramanujan was working with Hardy. G.H. Hardy, one of the famous pure mathematician of that time. Ramanujan went there and Mahalanobis went there, they met and they had a picture together that time. And Prashant Chandra Mahalanobis went there to learn statistics from Ronaldo Fisher. And he becomes so intrigued that later on he came to India and established Indian Statistical Institute, and he is still famous for Mahalanobis distance, a distance which works for skewed distribution and many other different problems where Euclidean distance does not work. So later on statistics started growing. So 19 to 1950 was the kind of the hot time for statistics, because World War was happening, and during World War many a discipline got boomed, just like industrial statistics, which people used to know as Six Sigma methodology, SQC, statistical quality control technique, Shewhart and all these big people, they came and they invented a lot of tools that will help the manufacturing companies to reduce their defects, because during the World War time you cannot produce some product which will be defective. You are buying a product just like this Chinese mobile, which will work or not you do not know, right, nowadays. That is not actual Chinese mobile, by the way. Chinese mobile are really good if you go to China and buy some mobile there. So, but most of the product you will be looking for a product which will work longer, like just like Apple. Why do people buy Apple? Because it works after 2-3 years. Some of the company phone, they do not work after 2-3 years. So you are looking for a product which will be very useful later on. So mostly Japanese people, Taguchi and those people, they came up with the idea of quality control, how to control the quality of some manufacturing product, just like car companies. They started using that and it became a fascinating field. Statistics altogether got into industry and it did the thing out there. Then after 1950, so statistics started working a lot during this time. P.C. Mahalanobis contributed a lot. Then after 1950, suddenly things started changing. That time Ronaldo Fisher and this Mahalanobis and this Galton, they invented all these tools, linear discriminant analysis, linear regression model, to study the relationship between different variables. Just like in case you are working in crop yield. So crop yield depend on many other factors, right? How much fertilizer you give, how much water you give, how much seed you are putting out there. So can we make a modeling equation, a mathematical equation based on that? Suppose y equal to a plus bx, something like that. Can we make a linear line like that? If we can do, then we can express the relationship between the independent variable in terms of the dependent variable. So dependent variable in terms of the independent variable. So this started happening back then, and they invented a lot of model, linear regression model, logistic regression model, all these models were built during that time. But then all on a sudden computer scientists, they thought, and mostly the name I should come up with, the first thing would be Alan Turing. Alan Turing is the person who actually led England to win the World Cup, not World Cup, sorry. Nowadays I am looking a lot of World Cup, that's and the World War II. Okay, Alan Turing invented a machine which will decode all the messages that Hitler was sending to his people, and he decoded that being in England. And that time something came up with something called, he invented a Bayesian machine learning algorithm, which later on was not published because Alan Turing was arrested, he put in jail because of the homosexuality and all these things happened. So, Alan Turing was the kind of the first machine learning guy out there, and that time people, some neurologists, they were working with brain. They started working with brain, how the neurons work. They started with coming something called perceptron model. Perceptron, how I am telling you something, so in your brain some of the things are getting captured, most of the things are getting out from there, and after that you are some people will be like hungry for the lunch and they are thinking like you should stop. So whatever you are recording out there, if I make a question, if I ask a question, some of you will be able to answer. So that thing, something in hidden layer, this is the hidden layer of the neural network, which is actually processing all the information that I am giving it to you. And if I ask you a question, you will give some answer. So that is why people started developing something artificial neural networks, and things got changed. People from statistics, they started shifting something called data science and machine learning stuffs. So from 1950 to 1970, there was a shifting going to happen, and that shift started making more noise when in 1970 there was something called AI winter that happened. That is the time when AI winter, artificial intelligence winter happened. They started naming everything called artificial intelligence. Even the basic statistical model got included in the machine learning paradigm, and then things got changing. People started developing more better prediction model than statistical model, but those models are also statistical in some way. And then statistics become a part of data science, or rather to say data science become a part of statistics, and nowadays people are working on machine learning and deep learning. So this is kind of the history of statistics, how it got evolved, and nowadays we are in 2022 where statistics, machine learning, all these terms not only we use but also we use daily. Just like today when I was coming from IIIT to here, I was using Google Map to understand the road and everything, right. So how Google will be knowing that this map will look like this if there is a canteen out here and everything? Some of us must have given that information that this is a canteen. Have you ever seen any drone is roaming around your house and collecting the data? Have you seen any drone or anything out there in your house, near your house? So how did Google got all those images of your house and everything? Satellite images, right? You might be telling satellite image. So some of you who is at the last bench, can you take a very clear picture of me from there, even if you have a good phone? Can you take a clear picture of a footballer from the end of the gallery? Your camera doesn't work, right? So you are taking satellite picture from the orbit, right? How far is it? Can you take a picture from 1 kilometer to another person, even with the best Sony glass and everything, right? Sony camera and all these things? It's impossible, right? So some people are actually using those images and making those images more clear. How can we make the images to read like a normal real image? That's what is done in image processing, and image processing is more of a statistical tool rather than like it's not a vague thing. It's like you take an image, you can process it in such a way that you can finally get the road out here from the orbit images, those images. So this is how things got developed. Right now if I buy a book in Flipkart, let's say the book name is Chetan Bhagat some book. Chetan Bhagat writes a lot of normal story book, right, which many people likes to read. So if you buy it, the next day they will be giving you some books by Robin Sharma and all these Chetan Bhagat type of writers who are writing all those love stories, right. So how they know how that Flipkart and Amazon is recommending things? Based on the purchase of the people, right. There was a famous thing that happened in Walmart. Walmart is like a big mart, you know, big bazaar and all these things in India. Walmart is like in US the kind of big bazaar, okay. You walk down there, you get everything out there. In most of the countries, like if you go outside, you will see hypermarket. Hypermarket is very popular outside. So you will get everything out there, everything. You will go and shop everything from there. So Walmart in 2008 came up with a very nice idea. There was a statistician who was working in Walmart. He said to his boss to put baby diapers. just like Huggies and all these things, to put with beer. He said those people who will be buying beer, they will be also buying Huggies or baby diaper. Walmart was shocked. This is one of the greatest correlation and study in Walmart that happened in 2008, which got published in Harvard Business Review. So they found out some people who are buying baby diaper, they are buying beer. How shocking is it, right? In India you can think it like that, no, right? But in US it was happening because of what? In US, suppose mother and father, the children's parents, they look after them and the baby will cry during night. All the babies, I think, they cry during night, okay? Whenever other people will sleep, they will cry. That's their like fundamental philosophy. And when they will start crying, they will be like, okay, I have to change the diaper, right? So they will change the diaper and they will be like pissed off, like my sleep got hammered. They will take a beer, drink a beer and then sleep. Common philosophy, right? But how did Walmart figure it out? Walmart, how many product Walmart used to sell? More than 10 lakh product. And out of that, how many customers they used to have in 10 years? Maybe more than 100 crore people. They formed such a big matrix, and therefrom they figured out that those people who are buying baby diaper and those people who are buying beer, there is a very high correlation. There is a very high association between that, maybe 0.9. Then they thought, okay, even if I have confirmed that, if you go to any US Walmart store, if you have the opportunity to go like later some places in Walmart, you will see the baby diaper is placed here, the beer and all the alcohols, they are placed nearby, which is very interesting finding. And that's how statistics help them to do that, okay? So now I'll come to my slide. I told a lot of stories already. So here from, why we are studying statistics? Because of this fact that the kind of data that Walmart had, if there was no statistician who was processing the data, figuring out the associationship, and that method is called association rule mining, finding the rule between the different products purchasing thing. If they didn't do it, we may not know that this thing can happen, or may not know many things can happen which nowadays we are using. Maybe something like the sales figure. Suppose if you are putting some sales, if you see right now I am working with a company as a consultant there, one of the pharma company. Whatever happens, mostly during the weekends the pharmaceutical sales drops down. I don't know why. Maybe during the weekend people don't get people don't feel like going to hospital, and this is real, right? Real thing. If you go to hospital, most of the even private hospital, they are open all the days, right? But on weekends there is less like patients out there. Why? Like people are getting only ill on the Monday and Sundays, like Monday and Tuesdays, not like that, right? But that's also some of the reasons that are happening. Whenever we can see their sales figure, we are plotting that on the after Friday it's getting dropped. And these are kind of events that are happening out there. So we have to model the forecast, we have to forecast the sale. What will be the future sales of some particular product like paracetamol or Calpol, all these things, right? During COVID we all must have taken them, right? We bought all the Calpol from the medicine store. We asked, whatever you have, give it to us. Like that will be only recovery thing for the COVID, right? So that time, all on a sudden, the Calpol production started increasing, because in normal, you don't eat Calpol, right, every day, right? So that's how, if I am a pharmaceutical forecaster, I have to forecast how many Calpol they will be producing for the next year. How can I tell them? I have to tell them by some means, right? I have to look at the previous data and figure out a forecasting model which will help them to do that. So this is how forecast and all these prediction models, they help us drawing conclusion, make decision, and help us to not to take the incorrect decisions. Now maybe I'll come to something called what are the kind of variability in the data. So statistics work when there are two things happening. One is the data has some variability, and the data, of course, by what we mean the variability. Suppose I take all of your heights. Do you think everyone out here will be 5'5"? No, right? So it's different, right? That's how it comes variability. But if I ask you to tell the multiplication table of 2, what it will be? 2 cross 2 1, 2 cross 2 4, 2 cross 1 2, 2 cross 2 4, 2 cross 3 6. Will it change? It will never change. 2 cross 9 will be something like 18, right? You don't have any variability out there. So this is how whenever there is variability in the data, we need statistics. Statistics tries to understand the variation, because our heights are different, because all the humans are different. That's why we have variation in us. That's why the earth is more beautiful, and that's why we need statistics to model those uncertainty. And there is another thing called uncertainty. Just like, can you confirmly tell that today around 7 o'clock it will be raining? Can you be 100% sure ever? Even Google is never 100% sure, right? They can tell, like they were telling like today it will be raining. On Tuesday I was seeing the forecast. They were telling like there will be a bit of rain today, but it's not raining. It's very like the weather is very nice, right? So there is something called uncertainty. Suppose you toss a coin, are you sure head is going to come? So it's uncertain and variable, because if you toss 10 times, head, tail, head, something like that will pop up, right? You don't know what will pop up. So these two things determine statistical data. Not all the data are statistical data. A multiplication table is not a statistical data. Or maybe if you look at the, like maybe Chinese people, their heights, more or less everyone is 5'3" or 5'4". If you see any, like if you have gone to China, I am not racist, but anyway, so it's mostly their heights are very equal. So there is not much variability. If there was 50 Chinese people were sitting, if I ask all of their heights, all of them will be taking 5'4", let's say, or 5'5". You will be shocked, and there is no variability. That's not statistical data. That doesn't need any analysis actually. So when we need analysis, when there is variability and uncertainty in the data. Next is, so this is very important for all of us. When we start doing research, we start with something by defining a problem. So statisticians like Taguchi and Shewart and all these people who invented industrial statistics, they told any problem is solved by a method called DMAIC method. What is DMAIC? Suppose we want to solve a problem in agriculture. We have to first define the problem, right? So if you go to your supervisor, they will ask you what is the problem, tell me the problem statement. You say I don't have any problem statement, I have seen a paper, I am going to replicate it for my data. They will say that's not a problem, define your own problem, right? So that is definition of problem, that happens the first thing. So just like in any industry also, people define the problem first. Then they measure how critical the problem is. What are the KPI of the problem? Key performance indicator of the problem, how much improvement can I make based on the problem. Then they start collecting the data based on their KPI, and then they analyze the data. So statistics come into picture mostly around these things. Other things also there are some statistical tool. Just like to identify what are the important measures, many times people use Gauss-Arner or something called like cause and effect diagram. What are the causes, what are the effects? Fishbone diagram, all these, there are a lot of diagrams, statistical diagram that helps us to understand and measure the criticality of the problem. And how much improvement do I need? Suppose I am going to make a new model for say harvesting of bee, like harvesting of honey from somewhere. So I already have a model that is used by my supervisor. He said me, can you improve the model? Then I will be trying to develop a new tool that will help us to solve the problem, right? So what is my KPI? I want to get more performance rather than the earlier model, right? So that my model will be more robust, more accurate. So how can we do that? So we, in the measure stage, we define that. We try to measure that. Then in the analyzing state, we try to figure out the root causes. That's why this is happening. Suppose the weather is changing. Why the weather is changing? Maybe due to many factors, humidity, sea level, the wind speed and many other things. So we need to know what are the root causes that is impacting the weather. That's why the temperature is changing, and that's why if I want to model temperature, I need all those causal variables or independent variables that impact the weather, that is the effect variable, right? So I need to build a cause and effect relationship from there, and during that time all the statistical measures, all the statistical tools, they become very handy. Whatever statistical tool we will be learning today are very handy for analyzing step, okay. and then improvement stage. Improvement means after running the model there, I will try to see whether my model really works or not. Indians are very good at making models. Just like I was during my PhD time, I was working with a company called Imperial Tobacco Company, ITC. Have you heard of ITC? Yeah, ITC has a very big thing here in Badrachalam. I went there, I was working in ITC PSPD, Specialty Paper Division. ITC make a paper for cigarettes, Marlboro and all these cigarettes, they used to be produced by ITC. The cigarette papers are very different from the paper that you use. Have you ever thought of the cigarette papers? If you burn it, it takes so much time to get burned, right? Whereas a general paper in which you are writing, just burn it, it will be taking less than 10-second time to get all the things will be destroyed. So how ITC produce that paper? So ITC produces paper from many things, among which pulp, water, lot of chemical lubricants and many other things are used out there in the production. So ITC was facing a problem, they were getting some dot on the paper. If you get a dot on your notebook, will you be buying it? Will you be buying Classmate notebook? Classmate, you know, is produced by ITC, right? It's very fresh, right? You will open it and you will see, okay, all the pages are very proper, right? If you take another notebook from any other company, it will be maybe some colors are coming or something like that, right? Some green or holes are there. Whenever there is a small, even small hole coming, ITC will be losing in crores, because the paper reel from which the notebooks are made, the paper will start from here and end at least towards the, like, if you see, it will be straight, a big thing, right? A big machine, they have 3 paper machines. On the paper rolls are like this much bigger. This like a paper roll will produce almost more than 5 lakhs notebooks, and if there is a hole, they will destroy all of it, because they cannot depend, they are very quality conscious people. And in case of the paper, just like in cigarettes, if there is a hole, your cigarette will be burned and the tobacco will be coming out from there. Will you be like smoking that? Smoking is dangerous and injurious to your health, okay. So, so you will not be doing that, right? So I was working there to solve that problem. Now you will ask me, you are a statistician, what you are doing there? That's an engineer job, right? So engineers also were there from IITs and IIT Kharagpur, and we had a very big team. We are working on how to solve that problem, chemical engineering problem. Finally, we could figure out that there was a problem with the water. The water they are using some drainage water inside it. And because it's not the water pH level, if it is below 5.7 and greater than 6.3, there will be a dot coming out there. So that's a model we built, and then the next step is try that model. We will be always maintaining the water pH level under that, so that the paper quality is very good. Then we tried to see that for 6 months. Then ITC paid a lot of money to ISI and IIT Kharagpur. So that's the improvement phase. So once you develop a model, you improvise that in the system where you are working and see how much impact you are making. You made your model, you published your paper, you left the country, that's not the case, okay, that shouldn't be the case. Then the last thing is control. So Indians are good at planning, Indians are always good at planning. So when I came to Bangalore in 2014 or 13 or 14, yeah, 14. That time I was seeing this metro happening, still now metro is happening, okay. So we planned a lot, we have the best planners in the world. We are very bad at execution, we make models, we cannot improvise it. During the COVID time, many of, like I was one of the person who was also trying to build forecast and give it to the government. So we had like I gave interviews in TV channels and many other places, but nothing happened, right? We had a very bad COVID, and you will ask me maybe what forecasting you made. We are telling to take these things, this precaution, we are telling to like how to define the lockdown. The lockdown was poorly defined. It shouldn't be like 3 months lockdown. It should be 15 days lockdown, then there will be breaking stage, and then you prevent people from doing this sort of thing, and many other things should be there. So epidemiological forecasting, epidemiological analysis is very difficult. But we tried to do it, we tried to put it to the government, but maybe the government later on never see anything what the epidemiologists and statisticians were telling. That is what happened in anything. I went to a seminar to give a talk at NSSO, National Sample Survey Organization. So there was the person who was presenting that was a very senior ISS officer, Indian Statistical Service officer. They are also grade A rank, like equal to IAS officers, you can think. So the director of NSSO was presenting something, and he was telling we had the best system, best statistical system in the world kind of. I said, then why we are not still, like why we say we are developing, right? We should be developed, right? Because we have the so much strong statistical system, we collect each and every data. What happens to that? So he said, like we collect everything, we do everything, but nothing happens later. So that's what we have to focus on, this improvement and controlling phase. Controlling means once we improve the process, we should be like reluctant and going home and sleeping. That's not going to happen. Just like, suppose think of it like this. How many of you know Sandeep Maheshwari? Many of you, right? You see, you hear all the motivational videos, right? After hearing motivational video, what you do? You take a break and think like I'll be from, like most of us are watching this video during night before sleep. It gives us good sleep. We'll think from tomorrow this is going to happen. Going to wake up at 5, maybe 5:30 will be fine. I'll walk because walking will make my body more flexible. 1 hour gym, then I'll come, drink only good food. Good food means I'll eat all the Pepsi, Coca-Cola, all these things next day, and everything will be lost. So that's what happens with all the models. We build model, we hear the theory, we try to apply it, but somehow we got lost. Everyone, every time we determine something, next day we will not be doing this. Like I have a very bad habit of eating the nails, okay. I tried many things. Now I am trying something called putting some lotion on my nails so that I don't eat it, okay. So these are the precaution I am taking, but whenever there is no lotion, I am feeling like now it's empty, let me eat it a little bit. So this is the problem, right? This is a general problem. This problem may not be happening in developed countries. They also have a lot of problem, but they try to control this. The control phase is very important. So they will be, once the quality is improved, they will be putting a bar out here so that they can stop the quality here. They can make it like that. They will be putting a threshold. I shouldn't be going below that. So I was because I'm teaching in the French system. French has something very important. In India, we might be having the brightest student, Sundar Pichai, all these big IIT graduates, ISI graduates, TIFRISC graduates, top students. Our last student is not even as like too far from French student. In French, their last student is better than our average student. They create the educational system in such a way that their last student will not be less than our average student. But we have the best students. Maybe their best student and our best student, if they compete, will win. But their last student, if they compete with our average, they will win. So they are controlling the variability within the student. In India, in any university, the topper get 99, the lowest marks is 20. You see the variability too high. The variability should be between 80 to 90. That's fine, right? All the students are good then. So this is the problem that is happening. So maybe when we will be defining our problem and solving it, we will be taking care of all these things. Now I will come to two things. One is, what is this probability theory and what is this inference, statistical inference. Today's mainly session was all about statistical inference. Now I am coming to that. So suppose I have a coin to toss, okay. Is there anything to erase this? Something to erase? Oh, on the board. No, it's fine. Oh. Thank you. You please sit. So I have a coin to toss, okay. So I have this coin in which head or tail is given. I'll toss it 10 times, and in high school I was asked a question, how many times, what is the probability of getting 5 heads, right? Or what if I got 2 heads in the first two toss, what is the probability getting 3rd head in the 3rd toss? And I'll be calculating all this, right? So, I am given with a population, this is called population. So, I know the population. From population, I am asked to count the probability for an event, which is a sample. Sample means coming up with 3 heads, 4 heads, 2 heads, 1 tail. Okay? So, from population to defining the probability of the sample, maybe population is tossing a coin twice, you will get head, 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 tail, tail, head, tail, tail. Now, what is the probability of head, head? All of us know the answer, 4 things 1 over 4, right? Only one time head, head come, right? So, this is called, from the, we have the population, we are going to the sample. Now, in reality, can we all collect, make a census and collect the data? Suppose Amazon is going to launch a new product, right? Can they go to all the Indians, 140 crore people, and ask them what product would you like to buy? Can they do it? What they will do? They will do a random survey. They will send the mail to their customers, they will get some information to know what they like, what they do not like, right. So, now we cannot do census. Maybe you have heard of census yesterday, right. So, we cannot perform census. We do not have the money just like Narendra Modi has. He can conduct census. Of course, he is the powerful Indian Prime Minister. He can do that, but we cannot do that. If we are a small company, we cannot make the census. Or suppose we want to understand the behavior of a particular product. Maybe if you are working in agriculture, suppose a particular seed, how much effective is it? How much effective the seed is to maybe to solve some problem. Can you go to every agricultural field in India and collect their data? No, you will be concentrated on particular sample. You will be choosing the sample. So, this is what probability does. So, probability's work is, given the population, we try to understand the sample. In statistical inference or in prediction, we do the opposite thing. We have sample, we try to understand about the population. Suppose when we write a paper, we will be telling, okay, under my jurisdiction, this particular place, say Bhadrachalam, I have worked on Bhadrachalam, all this plant, I collected their data and get the following model, and I can conclude the thing for Bhadrachalam, but because in India most of the farms are like that, so my conclusion will also happen in India. That is how we write our paper, right. So, suppose when we tell the dengue or COVID, when it will go out, right, we do not work with all the data. We take the data of say Bangalore and we see, okay, in Bangalore COVID is going to stop by this time, and Bangalore is so connected with south, all the south places and the north places. So, in India also it will stop by that time. So, we collect the data, we take the sample and we conclude about the population, global, generalize it, right. So, that is what is done in statistical inference. So, there is a very interesting thing which is called, this is data generating process. This is my observed data. So, from data generating process, population to sample, the thing that works is called probability. From observed data to talking about the data generating process of sample to population, this is done by statistical inference, SI. Okay. So, both the things are kind of inverse. So, statistical inference is nothing but inverse probability. Okay. In probability we have population, we talk about a sample. What is the probability of tomorrow there will be raining? Okay. But there we have the data of raining for the last 5 days. We comment what will happen in the large scale about the population. Okay. So, this is called the work of statistical inference, and this is the work of probability. Okay. Now, then there is another sort of thing. Statistics in general have 2 major phases, 2 major sectors of statistics. One sector is commenting on descriptive statistics, another is inferential statistics. If you have studied statistics, any statistics book if you open, they will distinguish 2 things. One is descriptive statistics, that is nothing but the art and science of data. What is art? In descriptive statistics, we try to understand different measures. Just like if I collect all of your heights, all of your weights, I will get some measure from there, your mean height, mean weight, average height, different median height, median salary for a company. Like if you are working, if you are going to enroll for some IITs, you will see median salary, median CTC after getting passing out, right. So, why do you see? You try to understand where I will lie after I join, what will be my average salary. We all consider ourselves as average, right. If the average guy is getting that, maybe I will be close by, either I will be topper or I will be loser, but does not matter, we are always focusing on the average, not some central value. So, statistics broadly has two major portions. One is called descriptive statistics, another is called statistical inference. Now, I will break them into several sections and I will discuss them all very quickly in the board. Okay. I will do it on the board because it will be fast then. So, statistics broadly have two major sections. One is descriptive statistics, another is inferential statistics. Descriptive statistics, this is not a general one, okay. I am doing it because for easy understanding. Descriptive statistics can be broadly classified into two segments. One is data visualization, another is some measurements, calculations, some measurements. And inferential statistics can be broadly classified into two things. One is parametric inference, another is non-parametric inference. I think it is getting too much technical, I will make it easy to understand. Okay. So, what is data visualization? Suppose I collect all of your heights. My question is to see how the heights are looking like. If I do a plot of the heights, how does it look like? Maybe my height is approximately 5'4" or 5'5". So, it will be like many of us will have around 5'3" to 5'6" or 5'7", right. So, maybe the height distribution, if I plot it, this is 5, almost nobody is lower than 5 and nobody is greater than 6 foot, let us say that. Okay. And if we plot it, maybe this is number of people. So, I have maybe 2 persons which is close to 5 to 5'3", and many people are in this region. So, it will look like this. So, these are kind of data visualization. Visualizing your data is most important. If you also visualize the last 1 year temperature, you will get to know that what will be the temperature of next few days. If you can properly visualize the stock prices for the last year, unless all on a sudden some black swan is happening, that is nothing but COVID coming, all on a sudden some Twitter CEO is resigning and everything is happening, then it is different. Otherwise, if you look at the past data and try to visualize it properly, the visualization will tell you many stories. That is why statistics is also, this is called art of statistics, not the science. Now, there is another thing called the science of statistics. Now, I am interested what is the average value of the height. Maybe I collect all of your values, then I do the averaging. We all know averaging, right. So, we will add all of them and divide it with the number of people out here. So, we will get the simple average, that is arithmetic mean, and we will say okay, the average height of these people are this. Then we might be interested how dispersed the heights are. Maybe I will collect the lowest person, the minimum height among the people and the maximum height among all the us, and I will take their difference, maximum minus minimum. That will give me an idea about how scattered the heights are. That is called range. Okay. Or maybe I will try to understand what is the distribution of these heights, maybe like normal distribution, bell shaped. It could be a skewed distribution, it could be a bell shaped distribution as well. So, this is how we try to understand the data. This is the very basic thing. Once you solve any particular problem, you collect the data, try to work on descriptive statistics, data visualization and statistical measures, then go for modeling, okay, because this gives us many ideas. Then another idea comes down, which is called inferential statistics. There are two ways to do the inferential statistics. One is parametric, another is non-parametric. To say what is parametric, I have to introduce you something called probability distribution. Do you all know what is probability distribution? You all know, right? So maybe we will do some very easy thing how to understand the probability distribution. So I have a population. This is my population. Population is head, 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 tail, 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 head. I tossed a coin twice. My sample, this is my sample, head, head, I am interested about. From the population, we derive something called the number of heads. We define a variable which is nothing but number of heads. How many number of heads are happening here in 4 experiments? 0, 1, 2. There is no 3, right? No, there is no time when 3 heads are coming. How many heads? Number of heads. So I defined a variable which is nothing but number of heads, which can take values 0, 1, 2. This variable is known as random variable. This variable is known as what? Random variable. Not because it varies randomly. Okay. The variable that converts the sample space to the real line. What is my sample space? What is my population? HTT, HTT. There is no number. You are converting it to in what? Numbers. What is my number? The number of heads. 0, 1, 2. Something that is mapping sample space into real line is called random variable. We do not need the definition for now. We need what is the distribution of x now. What is the distribution of this x? Maybe many of you can give me the answer. Have you heard of binomial distribution? The distribution of this will be binomial distribution because number of heads, right? Number of success and number of failures. So how can I do that? If I write maybe say head means success, success, failure, failure, success, failure, failure, success. Like that if I write, maybe if I toss the coin n times, how many times the head will come? Head means success. Let us say x times head will come, number of heads, heads coming. So out of n times, that is n choose x, I am getting success x times. What is the probability of success? If we take it p, p means between 0 to 1, some values between 0 to 1. The probability of success, or what is the chance of coming head? Maybe say you say half if it is a unbiased coin, right? It is a very, very easy problem, but it is not half mostly, right? So we do not know p, let us say. So it is p power x, p time p x times and 1 minus p n minus x time. So this is nothing but will come down to binomial distribution n choose x p power x 1 minus p power n minus x. Don't need to follow the derivations for now, but you get to know that from the population we can create a random variable. Its distribution is known as probability distribution. Probability distribution means if you sum the value, sum it, it will be 1, and all the probabilities will be always greater than equal to 0, right? Probabilities are never less than 0, right? When you say, we may say that no, just like yesterday's match, how many of you are following World Cup? Maybe, yeah. So if someone is following, then we all knew that France will be winning, right? Mostly. But also Morocco was winning some of the bigger match, right? So it was like a black swan, right? We couldn't predict it properly, but it's good that France won. But the thing is like this, right? So from population we can create a random variable. The distribution of random variable is known as what? Probability distribution, binomial distribution, normal distribution, all of your heights, weights, if I calculate, I can build a normal distribution from there. So there is another type of distribution out there, which is also a probability distribution, but not a random variables distribution. That is known as sampling distribution. What is sampling distribution? Now I will tell you. So from this sample that is collected, I create something called statistic. From this I create something called random variable. Its distribution is known as probability distribution. From the sample I create a statistic. There is the difference between statistic and statistics. At least after today's class you will be able to tell what is statistic and what is statistics. It's not like something else like the plural or singular form. It's not that. Okay? Statistics is the subject. Statistics is the key technology which helps us to analyze the data. How to interpret the data, it helps us. Statistic is something completely different. Statistics is the function of the sample. What is function of the sample? All of your heights I am going to collect. So you are telling all of your heights. Can I calculate the mean height? Yes. I will take all the values, I will add them up, divided with, say we are 50. Done. What is this called? Sample mean. Sample mean, right? This is known as statistic. What is statistic? A function, mathematical function of the samples. From the samples I make a function called x bar. X bar means average height. So this is called statistic. The distribution in statistics called sampling distribution. So both the things are different. Probability distribution and sampling distributions are different. Okay? Distribution of statistic is known as sampling distribution. Distribution of random variable is known as probability distribution. So even if you are teaching to some people statistics for biologists or some courses like that, you should be able to say these differences. Okay? Like this is very minimal thing. So whenever we work with statistic, okay, without s, that is nothing but your average height or your variance of the heights or range. Those things, their distributions are called sampling distribution, and sampling distributions are used to make the parametric and non-parametric inferences. Okay? In inference what will be useful? The sample, from the sample we will build a statistic, that is nothing but the average, that is nothing but the standard deviation, correlation, all these things from the data, and that we will be using to make the conclusion from the data using the statistical inference tool. Okay? And statistical inference is divided into parametric and non-parametric. Most of the thing now we will be doing are parametric, because we are assuming your heights following normal distribution. If we do not know what the heights are following, then it is called non-parametric inference. Okay? When you make the inference, when you do not know the distribution of the samples. Okay? So these are the two things we will be doing today on statistical inference. Okay. So these are the examples given in the thing. So I gave a very interesting example. I think elaborating the slides will be very difficult for me, because it is only 3 hours time, and maybe I will give you all the slides. Whatever I am telling, it is given with some examples. Okay. Let's just go through this example maybe quickly. TRP. What is TRP? Television rating point. Do you know all the channels they look for TRPs, right? All the news channels. How do they calculate TRP? Have you ever thought about it? Why do they say Star, Anand or some big channels, they have bigger TRPs, or some particular TV shows, they have more TRPs, KBC, Kaun Banega Crorepati, right? They have very big TRP. Kapil Sharma show has good TRPs. How do they calculate? Number of viewers is one thing, right? One of the thing, of course, out there. So this is a use to judge which program are viewed the most. This will give us an index of the choice of the people and also the popularity of a particular channel. So now you are using some tools, right? You are using say City Cable or something like that, Airtel TV or something like that. They have your system. They have installed a small box out there, which we call what called set-top box or something like that. Huh? Set-top box, right? So that box has a particular device which records what are the channels you are looking. Maybe you are spending too much time in news channels. Okay, some of them are using more time to watch football shows. So they are recording that, and they are giving the data to the top management that will be defining how much time on a particular show all the people are spending. on a particular show, if most of the people are watching that show, the most time is spent on that, that is what called people's meters, and that defines the TRP of the product, TRP of the channel. Okay. So, let us say we have a TRP data available with us. Let us say we have taken a data for 30 days period for some of the TV channels, and we have the following data available. So, now I defined what is the data and everything. We know what is data by now, we attended yesterday's class, right, day before yesterday's class. Let us say for the TRP we collect following information. This information collection is very difficult. This information is collected based on mobile. If you use mobile phones, they ask you what is your age, what is your sex, what is your how much happy you are after watching this show and all these things, right. In Netflix and all these things they collect this data, right. You all watch Netflix, Prime and all this, right. So, if they collect all the attributes, suppose they know my age, why they know my age? Because Netflix I log in by my Gmail, in Gmail I have put my birthday, or my birthday is this, you guys congratulate me, right. So, that is why I put it there, Netflix will get the birthday from there. So, they know my age, they know my sex, because that will be like the first thing when you fill the Netflix, they will ask male, female or mention not, right, they will know that. And then how much happy you are. So, when you are happy, you are watching the whole series. Suppose you are watching some TV shows, I was watching some movies yesterday like for some time, and then I found out it is bogus, like then I stopped it. They will know how much time you spend, you did not watch it full, right. Or maybe I was watching some movie Kantara, which is very nice, like very like story based movie, I really liked it, I watched it full time. Maybe if you are watching a movie 2.5 hours movie in 30 minutes, that means you are not interested. Okay. If you are watching it for minimum 2 hours, that means you are interested. You might be cutting the songs, maybe in between some people are dancing, you will not watch that. Okay. So, that is how you will be happy and not happy and more happy, all these things will be collected, and we can analyze the data based on this, the average amount of hours we are spending every day. Nowadays, this is not applicable for TV, right. We do not watch TV nowadays, we watch all the TV series, all the online platforms, right. So, suppose we have this data, the number of viewers watching, the age of these viewers, their sex, their happiness, their number of TV hours. So, this is the type of data that we can use for extracting some important information. What are the information we can extract from here? Let us try to see. We can define something called variable. Variables means this height, weight and all these things, which does not have a fixed value, right. So, that is why we define it as a variable. Variable can be of two types, one is qualitative and quantitative. If it is a number, say our height 5 feet 6 inch, it is a number, right. So, it is a quantitative variable, right, and qualitative variable may be sex. What is your sex, male or female? So, it is a qualitative variable, right, it is a categorical variable. So, I have for this data, how many categorical variables we have? Can you tell me? Age is a quantitative variable. What is sex? Qualitative. What is happiness? Qualitative. What is TV hours? Quantitative. So, we have two qualitative variable, two quantitative variable here. So, and the variable can be of, quantitative variable can be of two types. One is discrete variable, one is continuous variable. What is discrete variable? Suppose the height, your height is what? 5'4", 5'6", 5'8", it is a fixed number. So, it is called nothing but discrete variable for now. Suppose the temperature, can you tell what is the temperature today? What is the temperature now? Give me a guess. 23 to 24, nobody says 25.5, anyone said that? But if I ask your height, will you tell 5'4" to 5'9", will you tell that? That will look like something not good, right. So, temperature you are telling 24 to 26. So, you are observing it within a specified interval, right. So, that is what we call it as a say continuous variable. Okay. So, now if we have this data, how do we summarize the data? We have some discrete data, we have some continuous data, we have some categorical data. How do we understand this data? So, data understanding means this measurement. The measurements can be done in many ways. Okay. So, maybe this board is full, I will write here. So, to understand this data, suppose we have a data, okay. Say all of our heights, I have put it out here, these are our heights, okay. What is the first thing I am interested? I am going to be interested what is the location of this height, where most of the heights lie, that is going to be our average, right. So, the thing we are interested is called the tendency of height going to a central value, that is what known as measure of location, where the most of our heights are located, maybe 5 5, this is the region where most of our heights are located. This is called nothing but measure of location. How location is measured? Maybe by arithmetic mean, that is nothing but simple average, or by median, or by mode, right. We all know, I think, median and mode, right. What is median and mode? Let us compute for a data. Let us say we all have heights, very promising height, 5 6 7 only, okay. We will write that, so that the calculation becomes easy. 5 5 6 6 7 and 5, this is my data, 6 points, okay. This is our data, height data, okay. So, this is not the real data, okay, this cannot be real data. So, if I add them up and divided it by 6, this is what I will be getting, arithmetic mean, right, simple average. How do I get the median? Middlemost value, I will just sort the data. How do we sort the data? The data is already sorted. Sorted means from small to the largest value. So, what are the middle value? Leave these two, these two are middle values, right. Maybe I can say 5.5, taking their average, okay, or 5 or 6, both of them are median. What is their mode? Mode means the one which is occurring the most number of times, 5. So, my aim is something, my median is say 5.5 or 5 or 6, and mode is nothing but 5. So, these values will give me what? The location of the data, where the data are located, like all of our heights are located around this value, then I can say, okay. Then we do not need to use the whole data, we can say, okay, so if the people are passing out from ISI Kolkata, all of their salaries after masters they are passing out, most of them get the salaries between, nowadays it is between 15 lakh to 40 lakhs in India. So, the average salary if you see around 25 to 30 lakhs nowadays it is very high. When we studied it was around 13 or 14, okay. So, if we see, if we can tell, okay, so if we join ISI, we will be getting a salary of 25 lakhs after passing out, I will be amazed, right. So, we should try to join there, right. So, this is how by only a single value from the whole values I am figuring out a single value which is describing the whole data, I do not need the whole data anymore, okay. So, this is called location. Then the next thing is measure of dispersion. How dispersed is this data? How dispersed? Maybe the minimum value is 5, maximum value is 7, so it is dispersed. What is the dispersion value? Let us say 2. 2 means 7 minus 5. This is called range. So, a measure of dispersion, the scatteredness, how scattered the data is, how much distributed the data is, one of the measure is something called, that is called range. Range is nothing but 7 minus 5 equal to 2, maximum minus minimum. So, in a school, in a college, someone gets the salary, minimum is 15 lakhs, maximum is 50 lakhs, what is the range? 35, right. So, the range is huge. In a class where someone is getting 20, someone is getting 90 out of 100, then what is the range? So big, the data is varying so much, right. We do not want those variation in the data, and maybe it may so happen there is only one student who is getting 20, rest of us are getting more than 60. Only one person is getting 20, that person who never comes, you never seen him. All other people are getting more than 60 to 90. Then that guy is called outlier. Outlier means outside of the whole thing, right. If you plot it, it will be outside. If you plot the data from 60 to 90, all the people will lie between 60, this is my 60, this is 90. One guy is there who is 20 out here. This guy is not interesting to me. That is how in any data there could be some outlier values. Just like all on a sudden during some particular day, sometimes some stock price have fallen too rapidly. Just like when the day Elon Musk bought Twitter, that day was very significant, and all on a sudden Twitter price having a very strong problem. So, those particular days or those particular data points are known as outlier. Maybe you are working with some particular product, or you are suppose chemical engineer, you are putting something with something, maybe on some day the outside temperature was so high and you could not control the temperature and it got affected in your experiment, and that is how you get outlier values. Okay. Outlier is usually the guy in the class who is beyond our control. That guy will get score either, maybe that can be outlier, positive outlier. In our school there is a guy who is right now in Princeton, IAS Institute of Advanced Studies, he is studying. He used to get out of 100 99 in every exam, whatever be the exam is, minimum 99, 99 to 100. He then topped, he got very good rank in IIT and everything later after school, and we all used to get between 70 to 80, like not all, maybe some people were getting 50 to 80. We never crossed more than 80, and he was getting consistently 99, and all of our teachers will come and say, look at him, and we are like, why should I look at him? And he was the one, when we are in class 10, he was solving class 12 problems, and when we are in 11, he has already done all the like IIT JEE thing, and teachers used to come and say, okay, I am teaching it, you study your own, like you study your own stuff, I am teaching something else. There will always be like, he is also outlier, like he does not fall into our category. In class 10, like we all got around from 60 to 90%, many of us got, he got 94% during that time. Here he was 8 or 9 in the West Bengal, okay, in the whole West Bengal he was top 10, okay, from the school. So, he is an outlier, true outlier. These are also outliers. So, sometimes if you are doing some study, you are getting some data, sometimes all on a sudden you know that data will lie between 5 to 7, all on a sudden you got 10 and you will be excited, oh my god, I have cracked something, might be that might be outlier. That day something happened, or you falsely written as like that, or falsely you was about to write 5, you wrote 15, okay. So, that may happen. So, this is called outlier in the data, okay. So, there could be a value out here which is called outlier. Then there is another measure of doing it, is called standard deviation. Standard deviation, deviation from the standard value or deviation from the central value. We calculate it by taking the deviation from the mean. Mean is the simplest measure, mean is the most standard measure, not for the outlier data, but for the general data. If there is outlier, maybe median is the best measure. So, we talked about how to, when we have a data, one thing we understood how to get the location of the data, how to see how dispersed is the data looking like. I wrote all the disadvantages of single measures like mean, what are the disadvantages of mean. One basic disadvantage is when we have, suppose for the salary, why do not we write the mean is this? Because in IITs some people get 1 crore, most of the people they get 5 lakhs, 6 lakhs, 10 lakhs. So, if you add them up, divide 5 lakhs plus 1 crore divided by 2, what will it look like? More than 50 lakhs, does not make any sense. So, you rank them, you put them into order, you find the middlemost values. So, that is what going to be make sense, right. So, when there is outlier, mean does not make sense, and that is why mean is not a robust estimator. So, I will come to that, what is estimator and some of the things. Well, we discussed about median, this is the mathematical formula. So, we applied right 5 plus 6 by 2, so this is 5 plus 6 by 2, okay. The middlemost observation, if there are 2 observations in the middle, then we will add them up, divide by 2. If the data is 5, 6, 7, 8, 9, what is the middlemost value? 7. So, we do not need any derivation, we can just say 7 is the middlemost value, median. Then we have another important thing which we should be discussed about. Nowadays, if you are studying in any university, people say, what is your percentile? When you apply for JEE, they say, what is your percentile? 95 percentile. In you apply for CAT exam for MBA, they write about what is your percentile, right. How do they measure the percentile? Suppose we put all the values of our heights like this. Oh, this is. So, we put all our values like this, heights, and it looks something like this. This is nothing but my heights, right. So, this is in x axis I put heights, say, in y axis I put number of people in these heights, maybe say 5 2 5 3, there are say 10 people. In between these there are, I don't know why it's breaking, 12 people, like that. This is 15, this is 20. So, I know how this heights looks like. So, it is like a more of a normal distribution. So, the median of this distribution, the middlemost value of this distribution is known as 50th percentile, the middlemost value, and based on that, by 75 percentile, that value, that x 75 percentile, such that 75% of all the values of x are less than x 75%. So, it is nothing but I can cut off from here. So, this is my 75 percentile, say, this is my 25 percentile, and that is how percentile also sometimes makes more sense, just like in the case of JEE advanced rank and all this CAT percentile. And then there is something called quartile. So, when you hear about any company's improvement, very recently they will say Tata Q3 quarter 3 they got more, they generated more revenue than others, Tata Group, Tata Consulting Service maybe. So, that means their Q3 generation, that is the whole year, you can divide it into Q1, Q2, Q3, Q4, say. Let us say I divide it into Q1, Q2, Q3, Q4. First 3 months is Q1, second 3 months is Q2, third 3 months is Q3, and last October, November, December are Q4. Then I can say that what is my revenue from each of the quarter. So, this is like quarter, and from there I can define something very easy called quartile. What is that? So, if I have the whole data, this is my 10th percentile, that is nothing but what is less than in this particular blue region. Now, my quartile is the, first quartile is the 25 percentile, second quartile is the 25 to 50, that portion 50th percentile, Q3 is 75 and Q4 is rest. Like that I can divide the whole thing. This makes me easy to understand. Maybe suppose you are running a company, so you will be interested to see in which quarter you make the more profit, right. So, maybe Q3 is giving me, generating me more revenue. So, maybe during Q3 I will employ more trainees or more outside people, outsource more people to generate more revenues. Okay. This is how any data, any graphical version of the data helping us. Now, there is something called mode. Mode can be, there can be bimodal distributions where there are like number of times it is occurring, there could be two things which is occurring most number of times. So, that is my mode example. So, all these examples I have given it out here just for your sake. Now, the next thing is this particularly measure of dispersion. How dispersed the data is? We discussed about the range. Range is nothing but maximum minus minimum. Then another more robust measure of dispersion is something like that, which is called variance or standard deviation square. What is variance? How many of you here are from economics? Agriculture economics at least? Okay. So, have you heard of the term called volatility? Volatility? Volatility of the market. Right now, even if you open the newspaper, nowadays they will write, do not invest now money in stock market because the market is very volatile. Okay. And due to the inflation, people are raising the interest rate of the banks, right. The bank's interest rate, if you are earning some money, put it into FD, you will gain 8% interest now, and slowly it will increase. I think our prediction suggests that by 2023 you will be getting almost 9.5% interest if you put your money in Canara Bank or some private banks also. Okay. So, now if you invest in stock market, you will maybe lose money. Okay. So, because market is volatile, volatile means the variation. In economics, what we mean by volatility, in statistics we mean it by variation. The variation in the data. What is variation in the data? Suppose I have these height values, if I plot it, it looks something like this. Most of the values are between 5.4 to 5.5. Now I want to calculate the difference between the actual values and their central values. What is my central value? Mean, say mean. So I will calculate the difference between xi minus mean. For now I am writing mean as x bar. I think not many people teach using chalkboards here, that is why it is breaking, it is old enough. So I calculate all the differences between the actual values and the mean values, and then there are so many values, let us say we have 50 values, so I will just add them up, I will add them up. This is addition, okay. Sum means addition, okay. Sum means x1 minus x bar plus x2 minus x bar plus x3 minus x bar plus x50 minus x bar. What is x bar? Say 5, 5, okay. I will difference between them, I will take their square, I will take a square out here and do this and write it like this, and then I will add, because there are n samples, I will divide it with 1 over 50. For now, this is one of my measure of variance. Now there is something very tricky in statistics. Statistics is always tricky. So some teacher will write this definition of variance as 1 over n sum over xi minus x bar square. This is 1 over n sum over, that is adding them up, xi minus individual heights minus the average height square. Now some people will write it differently. How they will write? Why I am not taking xi minus x bar, you know? What will happen if I take xi minus x bar? Then suppose xi is 5.3 and x bar is 5.5, another xi is 5.7. If you add them, what it will be? It will be one case negative, one case positive, might be 0, no variation, right? It will be a wrong thing. Now you may say, some people will be a mathematician here, they will come and tell, okay, I will take modulus. Modulus means mod of a, everything is positive. That is also a measure, 1 over n sum over xi minus a, that is called MAD, mean deviation from the mean, absolute deviation from the mean. That is not a robust measure, you know, because always x bar, the modulus function is not differentiable, you cannot differentiate it. Can you differentiate it at any point? If you have studied mathematics in your high school, you have seen some function like mod x, right? Some of you have seen this, right? Mod x is whatever be the x, it will be coming positive, right? But if you draw this function, it will be like a problem, mod x equal to x when x is greater than equal to 0, mod x equal to minus x when x is less than 0, that is when there is minus 2, it will become minus 2 minus 2, that is plus. So mod minus 2 is equal to 2, mod 2 equal to 2, all of them are 2. So if you plot them, the function looks like this. This is x, y equal to x, this is y equal to minus x, okay. So this is a continuous function, but not a differentiable function. Why differentiation matters? Because sometimes we might need to do the derivative. Why do we do the derivative? Because suppose I derivative with respect to time, I try to find out dx by dt to understand. Suppose during the COVID, everyone was talking about some model called SIR model. Have you heard of this model? SIR model. Even in newspaper, even in TV, they were telling we have built some SIR model to forecast the trajectory of the COVID. Okay, they are giving some graphs, right? That is called susceptible, infected, recovered. What is susceptible? What is infected? What is recovered? Recovered means someone had COVID, they recovered from the COVID. Infected means someone is infected by the COVID. Susceptible means if I am infected by the COVID, my family is in stuck, right? My family is in travel. They are called the susceptible population. With whom I am staying, they are the susceptible. If I now do the derivative with respect to susceptible, with respect to time, I will get some equation which will give me the rate of inflation, rate of the susceptibility, right? What is the rate? So to get the rate, we need the derivative. That's why derivative is such a beautiful thing which gives us the rate always, right? With respect to time, with respect to other things, other quantities. So we need to sometimes differentiate this guy. So we cannot put the mod function. That's why other than the mod, what can we use? Maybe the square. Xi minus x bar square looks very interesting, right? It's a distance between two values and their square which is differentiable. So I take sometimes 1 over n to define the variance. So variance of x is defined by 1 over n sum over xi minus x bar square. Is it clear why this is called variation? Variation from the mean, from the central value, and you cannot take their modulus distance because modulus does not work, it is not differentiable. You cannot take single distance because it will be 0, plus minus 0. You need some value, square term, easy, right? And then adding all of them. So you get the variation. This is variation for everyone. Now you have to divide it with n because n samples are there, right, total. N means 50 people are there. Now statisticians, they made it more difficult for people. Sometimes they will use here 1 over n minus 1 and they will write this is nothing but s square. Sample variance, this is called population variance. For sample variance they will write 1 over n minus 1 and they will say okay, there is a reason for that. Why? That will be an unbiased estimator and all these reasons they will give. I will give you a very small reason, okay, for that. Sometimes we will be using 1 over n minus 1. Now 1 over n, say 1 over 50 and 1 over 51, does these values matter to you? Are they too different? 1 over 100 and 1 over 101, how much different they are? No, not much different, 0.001, 0.00111, blah blah blah, doesn't matter, right? So both values are very close, s square converges to sigma square, okay. And we can tell that n matters, the value of n and n minus 1 matters when n is small, n is 5, 5 minus 1, 4, 1 over 4, 0.25, 1 over 5, 0.20, differs, right? 1 over 100, 1 over 101 doesn't matter. So for you it doesn't matter. And for n to be less than 50, statistics doesn't work. For 3 people's height, if you tell the height of the other people will be this, and suppose all on a sudden you go to a class, you figure out the tallest guy out there. You say, what is your height? 6 feet. What is the next height? 6'2". You will tell, okay, the average height of this people is 6'2", 6'1". It will be a false, right? You need more samples. So for last sample it doesn't matter. But why do they use still? They use it because you have another relationship. You know that x bar is nothing but 1 over n sum over xi, right? You add all the heights divided with by n. So you know sum over xi here, this xi is dependent on x bar. That's what called degree of freedom. Freedom, how much movement you can do. Whatever movement you can do, you have to use one fact that 1 over n sum over xi minus x bar is equal to 0. This will always be 0, right? Because I told you, right, 1 will be plus, 1 will be minus, finally it will come down to 0. So this fact is there, this is what restriction. This restriction is there in this equation. That's why sometimes we put other than 1 over n, we put 1 over n minus 1. We don't take all the differences. Only for one differences, xi minus x bar, it will be 0, coming to 0. So all the n minus 1 differences we will take, okay. But for you, if you are applying to any real data, it won't make sense because for large n it doesn't make 1 over n or 1 over n minus 2. Samundar say if you may take some water from the river or sea, does it change the river? Doesn't change, right? Same applies for money, right? The money distribution in India, it follows Pareto distribution, people say. It's called Pareto law in economics. What is Pareto law? 80% people in India has less than 20% of the wealth. We belong to that category for sure. So maybe, but 20% people in India has more than 80% of the wealth. That's true, right? Ambani, Adani, all blah blah blah, they have all the money, right? So this is how, if you take some money from them, it doesn't matter. If they take your money, it matters, but they are still taking, right? So this is how it differs, okay? So that's why Pareto distribution is very little different from that. It's called 80:20 principle. It's like this, okay? It's a skewed distribution. Skewed means 20% of the people are getting 80% of the wealth. right, more than 80%. Even you can tell, if you take only Adani, that 5-6 people, Tata and Birla, all these people, it will be more than 95% maybe, right, maybe, right, I don't know, maybe Vijay Mallu has some out there. So this is how statistics is formed, this is how data becomes skewed. But in general, for any developed country, what would be the distribution? It would be a normal, right? People will have, majority of the people will have majority of the wealth, but it's not normal. For country like India, we have majority of the people having less money rather than the small portion of the people having all the money. Okay, this is the problem. That's why many people are working in economic inequality. Okay, that's also a very nice research area in India. I'm talking about economics because I worked on application of statistics. I worked on many a discipline. One is medicine, another is engineering, mechanical engineering, another is one of my work is in physics, chaotic systems, extreme events like the earthquake and all this I worked on. I worked on economics as well, unemployment rate and inflation, understanding their behavior using statistics and machine learning, and maybe some more which is not coming in my mind now. So this is some examples I have given. I already draw some examples, so it's fine, I think. So I'll go fast because the next talk will be by one of our students from IIIT, and they will not say anything, but they will be very upset if I don't give them time. So the range, and this is the calculation of variance and standard deviation. So variation is the most important thing in statistics. Anyway, in life, variation is the most important thing. When you see the next to your house, someone is buying car and everything, you see the variation, right? Like you don't have a car, their son has a car, and he failed in class 10 and still got a car. You don't like the variation, right? Do you like the variation? And if we all are equal, then also you don't like. Will you ever be able to see someone who is exactly like you around you always? Can you stay with your mirror always? No, right? That's also we don't know. So that's why we have to reduce the variation. Like, what is the solution? We cannot replica ourselves, right? We need someone who will be having less variation. Like the neighbors, they don't change much. So that means we are fine. Otherwise, I will gossip like, okay, mom, see, they are buying, they are doing some black market business and all these things, right? So this is how why in statistics, in any data, your job is to understand the variation, understand the variability. How to understand the variability? First quantifying them, first visualizing them, then quantifying them, then trying to reduce them by some manner. Now we will learn what are the manners to reduce the variability or to quantify the variability in a better way. Okay? So there is another measure called interquartile range, all these are there. So range and variation will work, okay, and standard deviation square is known as variation, okay, variance equal to standard deviation square. So whatever notation you use, it's just square term, okay. So this one I can erase for now. Then we wrote about data visualization. How do we visualize the data? I think this is the most important tool for anyone who is working with biology and agriculture. Whatever agriculture study I have seen so far, I was when I was in ISI Kolkata, at ISI Kolkata we have a unit called Agricultural and Ecological Research Unit, which is known as AERU. In case many people I could see from maybe agriculture, something like that. Is it so? Oh, okay. This side people are from agriculture mostly. This side people from? Overall it's life science, yeah. So maybe agriculture also comes under life science, a little bit, right? Should be. No, right? Some people will. Okay, we'll have a fight later. Maybe everything comes under science. Okay, let science be our god. Okay, so if we have any data in science, if we want to understand how we are growing and our neighbors are growing, how do we see the differences? We would be plotting what we did in the last 10 years and what they did in the last 10 years, right? That plot, the best plot that can give us those difference is nothing but a 5-point summary plot. This is known as in statistics called box plot. Box plot is the most useful plot which not only shows the location, the variation, the shape. It also shows the shape, it also shows the variation, it also shows the central value. So, it gives us everything, 5-point summary. And this is how, once suppose you are doing some experimental job, before the experiment you plot the data, after the experiment you plot the box plot, you keep the both box plot together and you show that after using my technology the seed production got increased, the crop production got increased. Maybe before I entered the project the crop production was looking like this. So, box plot will write down the interquartile range of the data. This is Q1, say Q3, this is my median and some hinge. Okay. So, if I plot this, if I plot the data, it will come down under a box. How will it come down under a box? So, I can count the Q1 and Q3 because I can divide the data into Q1, Q3, Q4, Q5, not Q3, Q4. Then I will write down Q1, Q3 and the median from the data I will get. Maybe before I entered the project, this was the crop production. This value is maybe some crop production means it's under ton, right? Maybe 100 ton, right? This is my average was 100 ton. Now, after I included a new pesticide, I developed in my PhD study a new pesticide, not new, nothing new. I modified some epsilon and make the new pesticide. Okay. There was a pesticide called sulfur, they was using sulfuric acid, I used some new nitrogen acid and made it. My chemistry is the worst, okay. I don't know chemistry at all. So after my new pesticide, it become, the box plot become like this, and I show this. This is before, this is after. Now, this is more dispersed, this is less dispersed. This has more production, this is 150 ton. Now, I will tell, if I give this plot in my paper, everyone will know, okay, this guy has make some big innovation by doing the epsilon change, in which we pay in paper, if the change is epsilon, we will make it, we will write it as innovative methodology we have developed, right, some earth breaking methodology we have developed, right. So, we will write it like that and we will show it by using this box plot. Okay. So, while writing paper you need to learn some writing tools, right. So, innovative tools, or we developed like or some novel, we created a novel methodology for understanding the behavior of this, trajectory of this and all these things, right. So, even if it is a small thing, we will make it bigger, okay. We will show it as bigger as we can. So, this is how the box plot will look like. Everyone is doing that, do not worry, in US also people are doing that. They are working with some real data, they are fitting some linear regression model in Stanford. I know many people, I can show you the papers as well, and that got published in PNAS. PNAS is Proceedings of National Academy of Sciences. PNAS, Nature, Science, if I have to tell 3 big science journals is Science, Nature, PNAS. Okay. Even in Nature, Science, all this, some very easy study they got published. How? Because they solve some bigger problem, they do not solve small problem. So, recently last year there was a paper coming in PNAS. PNAS means Proceedings of National Academy of Sciences, which has impact factor around 15 or 20, right there. And Nature Science has impact factor around 30, 40, even say 60, and right now I think is 60 or something like that. Okay. So, what they published, they studied 50,000 people, they were using smartphone, they tried to study all their behavior, what you do with your smartphone, when you use, how many times you shut up. Maybe some people, when we are anxious, what we do, we will open the phone, tuck, 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 close, open, tuck, 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 close. We do it, right, when we are anxious about something. Or maybe sometimes we will open some app and just stay there forever. Facebook scrolling, 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 nothing is coming. We want Facebook to give more ad, right. They will keep on adding some new pages, LinkedIn will keep on buffering, right. So, these things they started observing. They started observing more than 50 such variables from each human being, and they try to understand what is their depression level. And then these people were sent to some psychologist, they understood their depression level, and finally they fit a simple machine learning model for this data, simple, very simple, lasso regression and random forest, which is very simple machine learning model. Those of you have heard of machine learning, these are the common terms. That got published in PNAS last year. Because of what? Because of the like broadness of their study. They experimented with 50 people, they collected real data, and the data is so huge, so benefiting in that sense. If you collect some very important study, if your problem statement is very high, then even simple linear regression also can produce the bigger journal. Okay. So, this is one of the thing in research I have understood, though I started my PhD in 2016 and I finished in very short time, 3 years, so I couldn't get more time to study. But in ISI it is usually 6 years people finish. So, I was very quick in that, but what I understood by in that time ki, like major problem is finding the problem. A problem is solved when there is a problem. Well, any problem can be solved, and if you cannot solve that, suppose today I was supposed to come by nice road and the driver somehow convinced me that I will be coming through another road, okay, some highway he took. He told no, you won't go to nice road, we will have to take a lot of time, and then I was kind of asking him, we have to reach by 10 and it is getting late, we were stuck in the jam, and he took it personally. He said, I will drive, and he started like we are not driving, he was flying the car, okay, and we came by 10, okay, and he said, you see, I said perfect. So this is how. So in research also this is happening. In research, if we cannot reach to X, we will reach some other, we will find another new island which is called X bar. Okay. So in research, we start with here. So we are like Vasco da Gama. You have heard of Vasco da Gama. Wanted to come to a place, or Columbus, right? He wanted to come to India, but he discovered America. So you want to go to this island. All on a sudden, after 3 years of your PhD, you figure out, okay, that island is like, I don't know what island I have gone, but I have gone to this island. So I will name this island as my island, right? So this is my research, right? This is what happened in any research. Finally, we may not reach the goal, we may not solve the problem, but whatever we solve, that's my problem. So day before yesterday, I was having a meeting with a PhD student at IIIT Bangalore. She was trying to solve some problem in geoscience. She is a PhD scholar under Uttamda. Okay. So she solved some problem, but her problem is very uninteresting. She told the problem, and we all said, ki, this problem doesn't make sense. Then I told her, can we tell another problem for which this solution works? I told completely another problem. I said, how good is this problem? She said, this looks like big problem, right? But I said, you see, your solution works here as well. He said, oh yeah. Like I said, then this is your problem. That's not your problem, because she invests too much time and she is in her 4th year. Okay, she doesn't have too much time. So this is what happens. Okay, and to show improvement, whatever your methodology make the improvement, this box plot makes too much sense to show the difference between the earlier work and your work. Okay, so other than histogram, this is one of the most important tool. That tool is called histogram. When you plot the data values and their frequencies, and this box plot makes more sense to show the comparison study. Okay, I am too slow. Now finally I am coming to the today's syllabus called statistical inference. Okay, but finally we could come here at least. So we understood what is statistic, right? What is statistic? Function of a mathematical function from the sample, X bar, standard deviation. From the sample I can compute, right? So to understand the statistics, how it varies, we will try to study something called statistical inference. So I will write in board, then it will be fast. Otherwise, today there is no lunch. Okay. No, that won't happen. Don't worry. So I am also hungry. Okay. So in statistical inference, we broadly can classify statistical inference can be broadly classified into parametric and non-parametric, right? What is parametric? When I know the data distribution. When the data distribution is known, your heights follow normal. If you toss a coin, it follows binomial. You know that. When you don't know, it's non-parametric. Okay. So we have idea about data generating process. Now I'll come to something very interesting. Maybe some of you in future you will be using machine learning tools in your research, because nowadays if you write a paper, understanding the crop production in Bengaluru state using machine learning algorithm, that will get published in some journal, right. Using machine learning algorithm, that work will make the paper more standard, right. You use some machine learning and this makes more sense these days. So you will be using some of them, okay. So I will tell how this is connected with machine learning as well. So there are 3 terms I will introduce first here: prediction, the second term is estimation, the third term is attribution. I just wrote the key points here because otherwise I will tell many things and I will forget the most important stuff. I just noted down the prediction, estimation and attribution is written here because otherwise I will forget to tell about it, okay. So this is nothing but significance in other words. So prediction means what? Let us take an example. So we want to predict what will be the temperature of tomorrow. We want to predict what will be the buying price of a car. So you sell your car to a company, they will sell the second hand car, okay. There are many companies who give us second hand car. So what are the things you see in a car? Whether the car is in good shape, how much mile the car has driven. If it has already driven its lifetime thing, then I will not be buying it. How much year it was spent, how many people have used it, maybe it's 12, I am the 12th person who is buying it. So I will be like, okay, oh my god. So this it's going to be a problem. Whether what is the mileage of the car and other things, right. So I have all those data, I build a model. Model means mathematical form. Mathematical forms mean I will be taking the price. Previous cars what were sold, their prices are given, that is called Y value, okay. I am given with some attributes, that is the mileage of the car, x1, x2, x3. I will try to find out a mathematical relationship between them. So I have just say, for now I have y is equal to temperature, I want to understand the temperature. I know x1 is equal to the humidity. I know second is sea level, what is the other things, the wind speed, let us say wind speed, and many other variables I know. I want to build a relationship y equal to some functional relationship between x1, x2, xn plus some error, because in statistics everything is uncertain and there is variability. So nothing is certain. I cannot fit a line which is nothing but a straight line to this data. If I fit this line, this won't be very complicated, but we will be overfitting the data, right. I want to make a model which is simple but will be very close to all the data points, right. So this type of model is called regression model or classification model. What is classification model? Suppose I have the pictures of dogs and cats in your house. You have all the pictures of dogs and cats, you know this is dog, this is cat. How do we differ between dogs and cats? Nose size, ear size, right? You know, like, but you cannot tell like cats are more sweet or dogs are more sweet. Like sweetness you cannot measure. Someone is sweet, how do you measure that? You cannot tell. Nose size, ear size, hair, all these things you can measure. So those measurements you will take x1, x2, xn. Those measurements can be categorical or numerical, like qualitative, quantitative. Based on that you have y. Y is what? Either cat or dog. Classification, 2 classes are there. Based on the data you make the classification model. So this is what known as prediction. Okay. Finally, given a training set, given a data with attributes and with output, I know output could be of categorical or numerical type. I build a model, predictive model, which helps me to figure out something else. Maybe I make a model here based on all of our data. I take your height, weight, based on that I want to understand your blood pressure. Okay. I ask you, all of you, to write your height, all of you to write weight. I have a blood pressure measurement device. I take all of your blood pressure. I make a model. Now I wait for someone to come from the window, from the door. I ask, okay, wait, what is your height, what is your weight? She or he tells me her or his height or weights. Then I tell, okay, you wait. Now I build a model based on blood pressure is equal to say A into height plus B into weight. Now I ask her height and weight, I put it in the formula, I say okay, your blood pressure will be this, and I give, after I tell, I give her the measurement and I take it very close. She will be like, so this guy is an astrologer, please check my hand, Babaji, right? That will be the thing, right? Babaji, please tell, like what will happen in my life. So this is how. So it's not astrology, right? It's a science, right? So based on the data, you are building a model which is telling the future. Just like many people predict all these things. All on a sudden, before this Oxford University, they predicted the World Cup, who will win the World Cup, and they predicted Brazil will win the World Cup, and Brazil didn't qualify for the like semi-final. So it's like it's a mess. So sometimes models are not good. Models are simplification of the real life. Real life is not simple. Can you model a relationship between you and your mother and your sister with your mother? Who loves whom most? Can you build a model on that? So you will tell she loves me more, she will tell she loves me more. But you guys have some adjustment, like for this you will be preferred, for that she will be preferred, right? So real life things cannot be modeled properly, but we still try. So sometimes we fail. That's why Box is a very popular statistician, Box, B-O-X, Box. He told all models are wrong, but few models are useful, but some of them are useful. All models are wrong, truly. No models is perfect, but some of them are useful, right? Still today you know that tomorrow's temperature or day after tomorrow's temperature will not be exactly what is shown in your mobile, but you are still trusting them, right? Because based on that you will carry your umbrella or not carry your umbrella, right? And you are not going to do look at the sky, okay, it's looking like some cloud is there, okay, I'll take a umbrella. That used to happen. That used to happen. So that's what called astrology, right? Not science, right? So you build a model based on the mathematical tools, and you depend on that, which may fail sometimes because of the uncertainty and variability. All the uncertainty and variability we cannot capture. So let me come to the prediction. In prediction, we have all the sort of model. We are given with a data called xi, yi. Some values, some xi, some yi values. We make a model which will help me to predict the future events. Okay? So this type of model are called prediction model. Most of the statistical model and machine learning model, they are prediction models. And mostly very popularly used prediction model, I will give you a chart of all the prediction model at the very end as a cheat sheet. Okay? Now there is some model which is estimation model. Mostly statistical model helps us to do the estimation. Machine learning model is very far from doing the estimation, because statistical model are developed mostly based on the parametric inference idea, whereas machine learning models are built on non-parametric ideas. That's why they are not good for estimation. So just like if you start with a statistical model, if you give the temperature of last 30 days and you make the temperature forecasting for the next, this is the temperature, okay, may not be that bad, but it starts with maybe 20 to 35, okay, Celsius, okay. So my forecast is this. Statistical model may give you a forecast within a window. This is called confidence interval. An interval among this, the forecast will look like. Maybe most of the machine learning model, they cannot generate these things. That's called uncertainty quantification. Those who can quantify the uncertainty, maybe I can tell that tomorrow's temperature will lie between 25 to 29. That's my uncertainty quantification. I am quantifying there is an uncertain event going to happen. I am telling that uncertainty will lie between 4 degree, that is 25 to 29. So these things is helpful for estimation. Attribution means understanding the significance. How significant are those models, that is understood by ANOVA, analysis of variance techniques, and some other techniques. Okay. Now I will come down to slowly. So today we are trying to cover all the bachelor's in statistics syllabus in 3 hours. Okay, that's our target. So that's why we are too far. Okay, so but we will try. Okay, we will see how good is it. Now I am coming to something called parametric inference. Parametric inference, we will pose some problems. What is my problem? What is the average height of the students? Can you count it? Can you take all of your heights and calculate? We can calculate. Now there is a statistician in this KSTA. He is coming from there and telling, okay, you want to understand the heights of the student. I can tell you without getting your data. I am telling all of your heights, average will be 5'7". So, he tells something. Now, what is your job? You will believe him or not? Why will not you believe him? He is a statistics teacher at KSTA. You do not have any trust on KSTA people, right? What you will do? Either you will challenge or you will accept it, right? What he is telling, his hypothesis, his assertion, his understanding about all the people he have seen so far in KSTA, right? So, his assertion is also important. It is not like he is telling, just coming and telling, okay, 5'7", right? He has some idea in his mind, right? That is called null hypothesis. What is that called? Null hypothesis. Now, some of you are very brave. You do not have any trust on KSTA and you told, I will just challenge him, okay. So, you will go and say, okay, no, it is more than 5'7". Maybe who is the tallest person here, they will tell, no, it is greater than 5'7", because I contribute the most, I have 6'2". My contribution you are not taking at all, right. So, that is called alternative hypothesis. Now, we can do a test which is called whether the average height of the students are 5'7" or it is more than 5'7". We can do that. This is called testing of hypothesis. What is this called? Testing of hypothesis. In test, what we test? Some assertion, some understanding. Why do we test? Why are we testing? Can you tell? Whom we want to reject or whom we want to accept? Some person he came, he said something. He is all good. You guys are the one who is problem, right? You guys are the one who is telling you are wrong. So, why are you testing? You want to prove him wrong. You want to prove null hypothesis wrong. That is why, but null hypothesis is so strong that it is very difficult to force him or to say that you are wrong. You have to be very sure, very sure. How much sure is the best, best possible thing? When suppose I am going to tell the next match, because I am in French university, I am telling France will win. Anyone will challenge? Someone can challenge, right? Because I am one of the biggest fan of Messi. I honestly want Argentina to win. Okay, I honestly want. But I can see that France is very dominating team. You cannot beat them, right? They will not stop. Okay, so if I say, you say that Argentina will win. Now I tell, okay, let's do a bet. How much money I have? Even in my purse, I think I have almost 5,000. Okay, 5,000 bet. Will you bet me? When you will bet me? When you are 95% sure. You have to be sure to bet, right? That percentage of the risk you are going to take to do a bet with me is 5%. That is what called p-value. P-value is we take less than 5%, right, to reject the null hypothesis. The risk we incur to reject the null hypothesis is very strong. I am the guy, I know French will win. I know. I do not want your commitment anything, but I will bet with you if you just cross check with me. So, null hypothesis is something which is the understanding of people's behavior. Maybe your null hypothesis something might be like this. Suppose you are doing some experiment with some particular seed and that seed does not have any reproducibility or reproductive nature, right? Maybe, is there any seed which does not have reproductive nature? Huh? There are. Okay. So, that is my null hypothesis, that particular seed does not have any reproductive nature, and that is everyone has known that, because that seed is built on like that. Now, you do some epsilon changes with the seed and say that it has reproductive nature. So, your null hypothesis is very strong. If you want to neglect that, every other agricultural people or big scientists, they will just kill you, right? They are waiting with the gun. Where is this guy? I will kill him. So, you have to be so sure to validate that. You have to collect so much data to show that particular thing. So, your p-value or the risk you will incur to reject the null hypothesis should be very low. Your surety should be more. That is why we say when the p-value is the particular testing of hypothesis, we use a particular value called p-value to validate my hypothesis. If the risk is very low, less than 5%, I say okay, I am very sure. If my risk is more than 5%, I say no, maybe they will kill me, I will not do this, I will not write a paper on that. Okay. So, this is the fact of p-value. Now how does this p value come and everything? I will write it down from in the board. So there are two things. One is estimation. I will come to that later. Testing is more important because the syllabus they wrote testing mostly. So what is testing now? So now there is something. Suppose I am entering airport, okay? I am entering airport. Airport has a system. They will pass me through some thing like some detector, metal detector. They will say whether I am carrying some particular drug or gun or anything like that, okay? In India, they will also check you. They will touch all of your body. But in outside, if you go Dubai or Singapore airport, they will not touch you. They are very like they are nice people. You will just pass. Even with your luggage, you will just pass with your luggage. They will scan the whole thing. In India, we don't trust the system. We say, okay, still the system said you are okay, but I'll check your all the pockets. I love to check because we love to check what is happening in our next door, right? What they are eating today. Okay, we love it, right? So we'll check that. Now, suppose we are entering to the airport. I have a gun with me. Okay, system told that I don't have a gun. What is this? This is a problem. What I'll do? I'll be making the next 2011, right? What is the attack? America attack, the Laden attack. That will happening, right? I may enter and I'll make the mess. Okay. This is a problem. What is this? This is an system error. Another error. I am entering with a gun, without a gun, and the system said I am carrying a gun. What will happen? You are going to be treated very roughly for next 1 hour. They will search each and everything from you. Each and every single thing you have to open and show it to them. What you will lose? You will lose 1 hour of your life. Which is the most important error? The first one or the second one? First one will kill lot of people, and there you are losing just 1 hour of time. It's not like it's minor thing, right? So that's what these two errors are known as type 1 error or type 2 error. The first one is called type 1 error, second one is called type 2 error. So when I falsely reject a null hypothesis and when I wrongly accept a false null hypothesis. So all these things can be formulated as type 1 and type 2 error of the test. Type 1 error is the most vital thing. It needs to be, it's very dominating. You see, you are entering with the gun and they couldn't detect and you kill people. And like you say, like all these things like Mujahideen or kya tha, wo sab Jindabad ye sab karke you get out. Okay, so this is not going to be very good, right? So this is why in testing we try to reduce these two errors. But these two errors both are very problematic, right? Suppose I'm the security manager of, I'm one IAS officer and I'm wasting 1 hour of my time, which I can never be, but they are wasting my 1 hour time. Will I be okay? I will not be okay, right? If you and me, we pass through 1 hour of travel, we will be okay. What if Amit Shah is facing that problem? He will be like, I won't open, right? He will be like that, right? He is a like very charismatic character, right? So he will not be okay with that. Also sometimes some problem, we need to reduce the type 2 error. Which error to reduce? That depends on the versatility of the experiment. But mostly type 1 error reduction is most important. But together we cannot remove those two errors. We have to remove one error first. If we reduce one error, another error get increased. Okay, so this is always in life. If you want to like, that's why, how do we choose bride or groom for us? One thing is looking for the like good looking, very solid income, दोनों का ही होना चाहिए, बहुत ही highly educated, PhD दोनों का ही है, उसके बाद भी करोड़ों में कमाता है, ठीक है? Then what else? Family बहुत ही हाई फाई होगा, पूरा, मैं अगर ब्राह्मण होगा, मैं जो भी हूँ वही होगा, and family का तो reputation ऐसा होगा कि मतलब नाम से पहचाने सब, right? Everyone will know by their name. So all these things happens in imagination, right? All these things you can get in imagination. So you have to reduce one thing, balance one thing, right? Plus minus, last में जो भी मिले भगवान का दिया हुआ सब कुछ है, right? Last we all will be like, so this same thing, there is a story that happened with me and my supervisor. My supervisor was a very funny guy, and he used to like, he is kind of the supervisor 90% of the people have, who never contributed in my PhD but tried to push me up, okay, who never contributed, his contribution will be near 0, but he will always be pushing me up. So, I went to him after my second year of my PhD, I published 2 papers in good journal but not the best journal. I told him that I am very upset. He said, sit. He used to say, calm down, have water. Now he will give some gyan, okay, that you will remember forever, okay. He said, are you married? I said, no. He said, do you have a girlfriend? I said, no, but how is it related, right? I am asking you, I am not getting published in big journals and you are asking me these questions. He said, no, no, you see, you will get married one day. I said, perhaps. Then he said, okay, your family, what they will be looking for? He said all this criteria. Then he finally said, but after maybe 1 year, 2 years of finding, you will settle down to something, ये तो थोड़ा सा educated है, थोड़ा सा कमा लेता है, family भी ठीक है, देखने में भी चल जाएगा, बस ठीक है, हो जाए, शादी हो जाए अभी, right? नहीं तो कुमारा रहना है, right? Now, otherwise you will be unmarried for the whole life. Then you will settle down. I asked, sir, did you do the same thing? He said, no, I am not talking about me, I am talking about in general, okay? because I know his wife is very beautiful. That's why I asked, like, did you also do this same logic? He said, no, it's general, right? So that's how removing or reducing both the errors in any experiment is not possible. You cannot do that. So you have to be specified for which system, which error is most important. For airport system, type 1 error is most important. Maybe I can give some more example in which type 2 error will be useful, okay. So there are, based on your experiment, you will reduce 1 error. Now, how do we define these errors? And everything comes under the tool of testing of hypothesis. So now, so far, we learned about few things. One is called null hypothesis. Null hypothesis I defined as H naught, right? Alternative hypothesis, the null hypothesis is the statistician from KSTA whom you don't trust. That guy told the null hypothesis. Now, your hypothesis, you say I oppose, I am the kind of the Rahul Gandhi who oppose everything, right? So, alternative hypothesis. So, your H1. Then we learn something called p-value, how much risks I can take while rejecting null hypothesis. Null is very strong. That guy is KSTA faculty, he has a doctorate. He will not let you go out from the campus. So, if you are not 95% sure, you are going to be like being here for the whole day. So, the p-value. Then we learn something called type 1 error and type 2 error. 2 error we make, right? So, these are the common definitions that we use in testing of hypothesis. Now, I will do some special test after little bit of time spending on estimation, okay. I will come to that, okay. At what time we have lunch? 1:30. You guys are hungry? Hungry for knowledge? Okay. So then we can come for estimation. Now we will estimate something. What we will estimate? I want to estimate the average height of the people here. I want to know what is the average height of the people. What will be your answer? Take the sample mean, right? Take the mean. Some people will say take the median. Some people will take the mode. Not mode. Mode will not work here, right? Median also will not work because all the values are very close by, right? Mean may work here, right? So that's what called estimation. Estimation means estimating the value of the parameter. What is parameter? Parameter is something that signifies the population distribution. So here what is the population on which we are interested? The heights. What is the parameter there? Maybe the average value of the height, right? So just like normal distribution have two parameters. One is location, another is dispersion. Location is mu and dispersion is sigma square. So just like if I write down the normal distribution, this has two parameters. One is mu, that is equal to mean. Another is sigma square, that is equal to variance. So I write always x1, x2, xn follows normal with mu comma sigma square. Maybe IID. All the values are independently distributed. Does your height like depend on anyone else's height here? No, right? You don't have a sibling here, right? Then it doesn't depend. You don't have a twin here, right? Otherwise it depends, right? we assume that the data points, they do not depend on each other. But does it happen on the temperature? What if the temperature is there? Does temperature of yesterday depend on today? Yesterday it was raining heavily, today all on a sudden 40 degrees Celsius. Going to happen? Very unnatural, right? It depends. So these are called auto-correlated variable and uncorrelated variable, correlated or uncorrelated. So in this case, all these values are IID, independently and identically distributed. You are identical, that guy is identical, though you do not like mix up. Other than there is a twin of you out there. So this is the data in which we are interested about two parameters. One is mean, another is variance. One measures the location, another measures what? Dispersion. We want to test, we want to estimate the value of the mean and standard deviation. How do we estimate? That is done in estimation. How many ways we can estimate? Can you tell me? Estimating means what? I will estimate the value mean, right? The mean value could be, say you are someone who is very rigid. Like in life, you always determine, okay, I need, you go to your father and tell I need 500 rupees. You are not like, I need something like, if you give me 500 to 1000 is fine. You are very rigid person. Today I need 950. That's what called point. You are always interested in point value. So you want to estimate the mean as a point value, as an individual value, or someone else will be here to be interested on interval value, right? You want, when you ask money, you ask, can you give me 500 to 700? If you ask this, in India nobody will give you greater than 500. Will anyone give you? Your parents, if you tell, I need, can you give me 10,000 to 20,000? They'll say take 10,000, and even they will negotiate, come down to 1,000, right? But you are might be interested in some problem to get the point estimate value. In some problem you will be interested about the interval estimate value. So there are how many ways to estimate the parameters? Two ways. What are the ways? Point estimation and interval estimation. Let me write down here point and interval estimation. How do we estimate the point value? One way is by simply calculating the mean of the sample, right? I want to understand your average height. I want to understand the average height of Bengaluru. I have only your sample here, and I cannot go outside and ask people their height and weight. Some girl may clap me, right? Like really, right? So why are you asking me this? So but for you guys, because you are student, I can ask. Just like your supervisor may ask you many things that other people, if they ask, you will kill them, right? They will ask, today you study and give me the report by 9 p.m. or make a slide for me, right? And if you say no, then they will be, okay, bye bye. Next day your fellowship will be stopped, right? That's how supervisors are usually. So I am not like that. So I have my students, they ask me, they order me, can this is my paper, they give me 6-page paper, they tell, okay, it has to be 10 pages, can you make it 10 pages now? So it's like that mostly, opposite with me. So but that's another problem, because I have some French PhD student. They are like that. They will give you order. They will think this guy is an Indian, and I was having I was dominating in India for 300 years. So how can you order me like that? Okay, but that's a different issue, okay, altogether. So this is how we are interested about point and interval estimation. One way of estimating, getting point estimate, one of the most popular ways, maximum likelihood estimation. Now I will define what do you mean by likelihood. Okay, so many terms will pop up, but see, if you are hearing all these terms for the first time, so first time if someone teach you a whole subject for which is taught in 1-2 year, it is not possible, right? You might be getting lost. So that's why I will refer some very easy book, okay, which is like for everyone. Every single person in the world can read that book, provided they pass their high school in any subject, with any subject. At least till class 10 you all studied mathematics, that will be sufficient enough, and some notation will be required, okay, just like summation, okay, summation means adding, okay, just like that, okay. So let me come down to this. So this is my statistical inference, parametric, non-parametric, point estimation, testing of hypothesis, interval estimation, okay. We discussed all these things. Now point and interval estimation, we discussed what are these means, like testing of hypothesis, what does it mean. Now I will come you with one of the example. I will share the slide before you leave today. It will be with you. It will be downloaded in your laptop before you leave today's class and before I leave, because I am not going to come back tomorrow. So you will be having that, so you can take the pictures going home, okay, all of you, no worries. So maximum likelihood estimation is an way to estimate, get the point estimate of the parameter. Parameter is what here? Normal distribution parameter mu and sigma, right? What is maximum likelihood estimation? I tried to find out the easiest example, I could find out this one. Now it is up to you, you have to answer. Who is the daddy of this boy? This is his mother, by the way. You don't trust? It's real, honestly. This is not artificial picture. This is a real picture of a young boy. Don't judge this boy by his face and color, okay. This boy later on become the world's most dominating person, okay. This boy, this is Barack Obama with his mother, okay. Oh, he was right, you see, null hypothesis. So this is Barack Obama, by the way. So don't, and this is his mother, honestly, real mother. So can you tell who is his daddy here? And if you said, then tell me why. First one, why? First come to A. What is the problem with A? He is incapable of being a daddy? No, right? He looks fine, right? Why not A? Huh? So with similarity, with the picture, okay, no similarity. Second one, might be. Third one, who is third one, by the way? Bruce Lee. Barack Obama and Bruce Lee is not, that didn't happen. What is the fourth one? Huh? Maybe. So you guys are doubtful about two people who are black, right? So shameful for you, right? So much, right? This is not good at all, right? If you are in America, this is not good. White people and black people you have separated, and you are asking black people will be the daddy, right? But why do you choose based on the color? For now, the similarity, right? Not the face is similar. You didn't see the face of Barack Obama's young time very properly. I don't think you have looked into his eyes and putting cross mapping that, right? Only the color and mostly because his mother looks very different, right? So let's figure out. The child appears to be mixed race parentage, right? His mother is white. Father is, there are 4 daddy, possible daddy. Don't post this in internet, okay? Because Barack Obama is very popular, and if you post it, I will post the PPT, put your name in the PPT, okay? So A is the least likely. A is a very handsome guy whose name is, who is a very popular statistician actually. A is a very popular statistician's picture, okay? I will come to that. 4 possible option, A is least likely. Daddy C is the next least likely because of the appearance. Daddy B and D is the option. If we had more information such like blood type, DNA or history of the 2 men, then we might be, what would you do if you guys are biologists and life science people, you are telling about like that, you will tell I will do the DNA test. That is the first thing you will do, right? So you will ask Barack Obama and that guy to do the DNA test, but don't ask for Barack Obama, you can do it for other people. So we would never be certain that anyone's daddy is who is the real daddy. We simply accept the one which is more likely choice. Every daddy is MLE daddy, maximum likelihood estimate. These are all the estimates of the daddy, right? So these are the daddies we have. So now let me reveal who are these people. The child is Barack Obama and his mother. Daddy D is nothing but an actor, Sidney Poitier. C is Bruce Lee. A is Professor Alan Agrestri, whose book I will be referring at the end, that is why I put his name. Very popular statistics icon from UK. B is the actually Barack Obama senior. Okay, so those who win, they will be getting today 2 papad instead of 1, okay, during the lunch. So what is maximum likelihood estimation? Maximum likelihood is nothing but when we talk about any probability distribution, we can write it in mathematical form, and their integration, if we add them up or if we sum them up, it becomes 1. So, it is a function with mu and sigma and x that will be summed up to 1. That is what normal probability distribution look like. It looks like a very traumatic thing in general, but I'll just write it down, then I'll tell how it explain things. Okay. So, normal distribution, this normal curve, if I write down its mathematical equation, so even there is a mathematical equation for love. You all at least have written love symbol in your notebook during your school or colleges, right? Not with someone names, but at least drawn it, right? Just to feel yourself. If you are single, you made yourself feel like I am lovable. If you are with someone, you put 2 names and put a cross, and maybe that name does not exist nowadays. So, a normal distribution is represented by a particular function f, which is the probability density function. Variable is x, my parameter is mu comma sigma square. I write it down as follows. Do not worry about this nasty mathematical thing. E power minus 1 over 2 sigma square okay. So I am not putting this sum because it will come down to the MLE calculation. Okay, right? Is it correct? Have you seen anyone seen this normal? Okay, 1 over sigma root over 2 pi e power minus half x minus mu by sigma square. It looks very nasty. Okay, doesn't look very nice, but when you plot it, it looks very nice. You see, that's what life is like. If you get an equation of love, it's a big equation. The equation will make you feel love is that much complex. Honestly, that time you will understand why love is so complex thing, right? That also normal life, normal things is so easy, but when you put it into equation, it's so complex, right? So this guy is nothing but known as the probability density function. Probability density function. So what is the likelihood of a data? Likelihood is nothing but the product of the probabilities. Product of the probabilities. Product of the probability density function values. So this will give me the likelihood of the data. That is nothing but their joint density function. Don't worry about this. Say we have several values and we want to figure out what is the likelihood. So I'll have many ways to figure it out. That suppose I know the distribution is normal, I'll product the normal distribution values and do a derivative of that and equate to 0. How do we find out the maxima and minima? Do the first derivative, equate with 0. Have you seen derivative? Most of you seen, right? So derivative is nothing but finding the rate. So you find the first rate, equate with 0, get the value of mu and sigma and try to figure out the double derivative. If it is greater than 0, it is minima, less than 0, maxima, all these things you do. Okay? This is mathematical. Let us forget about that. So by this way we can figure out something called maximum likelihood estimation. And because the product of the probabilities, suppose I'll give you an easy example. Let us take this example, maybe this will be easy. Let us take x is a thing, x takes value 1, 2, 3 and their probabilities are 0.2, 0.3, 0.4. Can we calculate the likelihood here? Can you tell me the likelihood? We have to figure out its density, right? This is discrete case. So this is nothing but not density. This is called mass function. You have to figure out the mass function first. But I made a small mistake here. I have to put 1, 4 because the probability is not adding to 1. If it adds to 1, I can figure out a multinomial distribution from here. Let us not get into that. From there, I can figure out something called their products. Probability product means it is a very small value. Probability means 0 to 1. If you multiply multiple 0 to 1 values, some value 0.5 into 0.5, what it becomes? 0. It is greater than or less than 0.5? Less than 0.5. That is the problem. If you keep on multiplying small values, it will become more lesser. So, you cannot estimate that. That is why we take log likelihood. If we take log, log means the values will get increased, right. Log 0.1 means log 1 by 10, okay, 10 inverse, right. So, this is how we calculate the maximum likelihood. This is actually itself requires a specific 3 hours class to teach log likelihood and all these things, but this is one of the simplest way to calculate the log likelihood value, do the derivative and get the value of the parameter estimate, and this is most popularly used in any statistical model. Even if you are using any linear regression model, logistic regression model, I am quite sure in the system, if you are using SPSS, SAS, Minitab, any other software, GRASS, any other software, they are using this maximum likelihood estimation. Okay. So, for now we will move from here and go to the testing. Then the interval estimation. Interval estimation will give me a value within that range it will likely to be happening. Okay. So, maybe tomorrow's temperature is going to lie between 24 to 26. So, what does that mean? So, probability of tomorrow's temperature lying between this, if we observe this multiple times, maybe 100 times, 95% of the time it will be lying between that time. But what if, that is why statisticians are never sure. They are like, if you ask a statistician, will you marry me? They will say in 95% confidence interval. So, maybe things get changed. So, so this is how it always works, right. So, in general we are never sure, and like being 100% sure is nothing, like that may not be possible ever, right. So, this is why we want an interval which is more than 90% sure, 95% sure. That is why we want an estimate which will lie between certain range with a surety of more than 90%, 95% if we observe it repeatedly. This is not a single definition, this is a sampling based definition. If we sample from the population repeated 100 times, 95% of the time or 95 times, that value of the parameter tomorrow's temperature will lie between 24 to 26. Now, if it fails, you will tell, okay, so my it lies between 5%. I told you 5% is like, you are not getting married with the same person, you will tell you lie between the 5%, I told you the 5% risk, and this is what happening in life. Okay. So, this is how you can calculate the interval estimate of the value. This is some technical thing, so we do not have too much time. Just like an example of this interval estimation is like putting the net in the water. When the fisherman, okay, so those who are in fishery, they are smiling now. So, they put the like what is called net, right, net, fishing net, they will put the net out there and they know where all the machlis, right, like all the fishes are around, right. They are very sure, they will put it there, they will pull it up. They know the confidence interval, this is like the confidence interval. If they put it many a times in the different places, what will happen? And no fishes comes up, they will be like hungry, like they will not get any food for that day, right. Just like now you think of a bigger problem. Why this is more important? I am kind of involved with total energies. Do you know total energies? Total energies, they extract oil from, I have seen many offices of Total and Thales out here. If you are around in Bangalore city, you will see total energies symbol. They have some oil, right, the oil pump here. So, what they do? They bring the oil from the underwater. Underwater means under the sea. When Iran, Iraq, all these people got the oil are in crude form. I am not the best person to talk about oil, but oil was in crude form and oil was there maybe more than 100 foot deeper in the sea. Now, you will send people 100 foot deeper and you will ask them to break the ground and pull up the oil. How will you find out where is the oil? Now, if India start doing that, everyone will be under the water and finding that, right. So, you have to find some mechanism in which you may know there is a possibility of having oil there. You have to be more than 90% sure. In case of oil, if we are 50% plus sure, we try to dig that position, and digging take lot of money, It is like underwater more than 100 feet under the sea. So, you have to make a base camp out there under the sea and then search for it. How do we find out that? Where there will be oil, that position, the evaporation or like the wave will be there very stronger. So, they have lot of wavelet coherence plot and many other approaches in physics, geophysics to apply, so that they can understand based on some sensors that there might be something happening, so that there the water purification or the water intensity is different there might be some oil, and they start digging. Just like now, yesterday I was reading in West Bengal, in Gangas, they are going to dig some places. They thought, some geophysicists told that there might be some oil. If they get it, maybe Mamata Banerjee will be the next PM. If they do not get it, Mamata Banerjee may lose. Okay. So this is how. So you want the interval estimate to be very close. So suppose I ask you, what is the interval estimate of your for tomorrow's temperature? You said 20 to 40. I say, what I will do with that? I know it will always lie between, you said 0 to 40. It will always lie between that, right? That is not an interval estimate, that is not an estimate at all. That is a rubbish, right? If you say 20 to 25, that is still an estimate. So you want to be if you are a fisherman, you are putting it where the fishes lie, not the whole sea. The fisherman, what they could do? They could put the net all over the river, then they will definitely get good amount of fish, right? Can they do that? That is very cost inefficient, right? So that is why interval estimate should be very close to the actual estimate. I gave some example here. So now I am coming to hypothesis testing. Maybe I will take some maybe some half an hour after lunch, and then Madhurima will continue with the hands on, okay, which is also very interesting. I will also be there to help you. So hypothesis testing in statistical inference. So the best example of hypothesis testing is nothing but our judicial system. They say that judicial system is like, it's blindfolded, right, because it does not see whom they are going to put in behind the bar. They just want to see the evidences, right. More promisingly, you have to find out the evidence, strong evidence to make someone putting behind the bar, not in India sometimes, but also if it is Salman Khan, there is no bar, Tere naam will come, right, all on a sudden. And otherwise, in general, if you are going to put someone, give someone a lifelong imprisonment, you have to be very sure, you have to put strong evidence. So my null hypothesis, a hypothesis about value of a population parameter, is an assertion. And suppose I am the sample whom police arrested here, because maybe in Bengaluru, when I was here around 2014-15, that time one of my friend was smoking outside, and he has to give 500 rupees fine. That time, like if I strongly remember, it was in the Samsung, what is called Samsung Opera House. Have you been to Samsung Opera House? There is a Samsung Opera House in MG Road. Okay, yeah, it's a very nice place. MG Road in general, a lot of bars and everything out there, right? So hot and happening place. So my friend was smoking, and the policeman came and took 500. So suppose someone got arrested for that. The person does not have 500 and got arrested. So he will have a lawyer. Okay. If you cannot get a lawyer, the court will give you a lawyer. Okay. And there is an alternative lawyer who will be working for the policeman, right. So these two lawyers are going to fight. Okay. So I will define null hypothesis, type 1 error, type 2 error based on all these example. Okay. So an useful analogy for statistical decision making is the decision process used by jury in a legal proceeding. In a criminal trial, this is not a criminal trial, this is also criminal, right. This is not civil. Civil is like more the land and all these things, right. So the null hypothesis is that the defendant is not guilty. The null, you will always take that the defendant is not guilty. Why? Because like otherwise, if you always assume the null is guilty, then you are going to put him in the bar. And in general, in Indian judicial system, if the person does not have money, he is taken as guilty. That is the first thing, right. If it is Salman Khan, he is not guilty. But in general, the strong judicial system will always understand that the person who is arrested is not guilty. Otherwise, you need evidence to prove him guilty, right. Otherwise, you are claiming someone is guilty and you are putting him in bar. That is not the case, right. He is arrested, that means there is a problem, that means there exists an alternative hypothesis, he could be guilty. Now we will need evidence to prove him guilty, right. So, the alternative is of course the person is guilty. The benefit of the doubt goes to the null hypothesis. If you do not have strong proof, what you will do? You will put the person in bar? No, right? You do not have proof whether he did it or not. So, you will be okay, it is fine. Just like for big people, the most important people in that sense, celebrities and all this, most of the time there people like the court could not find any strong evidence. So, they have to leave that person, right. So, that is what happens. If there is not strong evidence, then the judge will say, okay, the benefit of doubt goes to the person who is arrested for that, we will leave him. The burden of proof is on the prosecution to demonstrate that the assumption of not guilty is incorrect. So, now the prosecution will have to come up with something, we will have to come up with some proof that this person guilty. What is the proof here in case of smoking? Maybe I will be the one proof, maybe, right. I was there, I was seeing that person was smoking, right, but he is my friend, I will say I do not know, I may say, right, that. What we will do? If you are a good friend, you may still say that he did, but if you are very obedient friend, then you will not say, right, and you know that in 500 you can get 3 beers, right. So, you will say okay, let us save it. But what is another proof? The policeman. If the policeman says that the person was smoking, there might be a case. They will try to understand like he is not lying maybe, right, based on his reputation and everything. And if the policeman has been charged for many other things, the prosecution will say this policeman, he always tells lie. He takes a bride every single day, so you should not hear him, right. So, that is how the juror must only vote for the guilty if they are convicted beyond reasonable doubt that the defendant is guilty. So, this is the decision process what will look like. Assume the defendant is not guilty. So, assume that he did not smoke. Evaluate the evidence in the light of assumption. Could all the evidence presented simply be a coincidence? Just like maybe he was not smoking, someone else behind was smoking and they found it. In case of smoking this does not happen, but in case of murder and anything this could happen, right. It might be just like Drishyam. In Drishyam it was shown like what is like reflection, right, what you are seeing it is going to, it is not the case always, right. So, we will be, what is the chance of that? What is mean by beyond reasonable doubt? What do we mean by benefit of doubt? What is mean by burden of proof? Burden of proof is on the alternative hypothesis, just like the professor from KSTA came and told 5'7". You said no, the height is greater than 5'7". You have the burden of proof, you have to collect the data and say you are wrong. He is not going to do that, he is a promising statistician, he is having his own words, you have to prove it. So, the burden of proof is on the alternative. If you neglect any of the hypothesis in your research, you are working on some hypothesis, you want to show it is wrong, you have to carry out with an experiment many data and show that it is against that, and that is what test of hypothesis will help you to do it. Okay. So, the same question must be asked as we make a statistical definition as they asked above the juror. So, we form a null hypothesis and then we can form also a alternative hypothesis from here. Now, I gave some more examples of these things. Okay. So, we will not going to that, we are going to that same example maybe. So, we already learned what is null hypothesis, what is alternative hypothesis, right. So, maybe I gave some examples of more null hypothesis and alternative hypothesis. Null hypothesis is here the statistician from KSTA is claiming the height is 5'7" and you are telling alternative, that is the alternative, greater than or less than, right, or maybe not equal to all this. So, these are the different type of null and alternative. Alternative could be greater than, less than, not equal to, like that, and they are mostly these two hypotheses are exclusive and exhaustive in nature. So, if the hypothesis is greater than only or less than only, they are called one sided test. Okay. If it is not equal to, that means it could be greater than or less than both, then it is called two sided test. Okay. So, all these are basic notations, not tough, maybe if you are hearing it for the first or second time, it is getting tough, but it is easy. Okay. If you read it further, then it will be easy. Maybe I will go to this type 1 and type 2 error now. What is type 1 error? So, my observation is H naught is true, okay, and I accepted it. Maybe I am carrying the gun or I am not carrying the gun. Okay. What is the decision? The system detected I carry the gun. If I am going with a gun, system detects I carrying the gun. What is it? Correct decision. If I am going without the gun, system detect I am not going with the gun. What is that? Correct. I am going with the gun. The system detect I am not going with the gun. System detect I am not going with the gun. I am going with the gun. Error. I am not going with the gun. System detect I am going with the gun. Error. Type 2 error. Okay. So, this is how we can define type 1 and type 2 error in general. In general, we focus on type 2 error, but type 1 error, but type 2 error is also important. So, test statistics can be obtained based on this. We will come to that a little. Okay. So, there are many ways to do the hypothesis test. We will talk about a few statistical tests after the lunch, because otherwise some people are already yearning, like, so it's getting heavy. Okay. Maybe after lunch I will not take much time, but during lunch and in between time I would ask all of you to download a few things for the next session. Now I will just show you the website, you just download it in your not mobile laptop okay, or computer. Okay. I will just go to 2 websites and I will ask you to download them for the practical class. Internet will work here. Write down CRAN R project. Can you write it down and search it? If you do not have a laptop, it is fine, you can write it in your notebook and search it in your computer. If you have computer, search it. Okay. CRAN, CRAN, CRAN space R space Windows, or no, space project, sorry. All of you are using Windows laptop or Mac? Is there anyone having Mac? Windows. So, then it will be easy. Okay. So, CRAN R project to Windows. Okay. Are you getting something like this? Anyone in computer? CRAN R, there is no internet, who is so far is having, is coming? CRAN, CRAN space R, okay, space project. Okay. If I enter this, this will come. Are you getting something like this? So, you click on the link, okay, it will open a software download link like this. Oh my god, it is very fast. Okay.